Oh, come on, Lisa. Shut up. This is ridiculous.
So, what have we got so far? Any brilliant ideas for the anniversary?
People, program, process, popcorn, and party.
Pole dance.
Professionalism.
We show people. Professional people.
Smiling people? No, please. Not just a parade of happy faces.
People,
Talking about where they're from.
No time for that. And how does that connect to additive manufacturing?
Right. Because they're holding something. A part. A cool design. Something 3D printed.
Let's hope your enthusiasm can save the pitch at 11. We'll need all of it.
Let's show the products. Think of commercials. For car porn style. This is gonna be hot.
Why not add some bad taste erotic music?
Let's not.
Yeah, let's not.
This project is killing me. It has to be something special.
Something special, something specific, specific industries.
Aviation and aerospace? Lightweight is important to them. Engineering and construction? Definitely big ones in 3D printing. They'd love to see that too. And jewelry is on the rise. They sure expect more visitors from this sector. Don't even think about bringing up Paul.
But he was the secret star of the last exhibition.
Still can't believe it.
What about the faces behind Formnext, the organizing team? We have event management, sales and customer care, marketing and communication.
Exhibitor services, new sales, and the management. With Christoph, Sasha, and, of course, Petra. Though I can already hear her say, I don't think this is gonna work that way.
Can we cover the entire process chain?
The entire process chain?
The entire process chain.
Epic film.
An epic film with huge machines and massive booths.
In slow motion.
Awesome.
Awesome.
Awesome. Awesome.
That's literally every other trade show video.
Let's break expectations and we finally deliver something truly fresh. We show how AM works in production.
Done that already. Application Insight at Audi 2023.
Or we show the unique benefits of 3D printed parts made of special materials.
Done that already. Technical Ceramics, Exhibitor Focus 2024.
Or we dive into different 3D printing technologies.
SLS and SLA Technology, Exhibitor Spotlight 2022. Done that already.
Done that already.
Yeah, we do that every year. We need to nail this. We need to deliver something truly special.
So what do you suggest?
How about we finish with a conga line?
Oh, come on, Lisa. Shut up. This is ridiculous.
Woke up this morning, now watch me step. The week was murder. I'm gonna get rid of the stress. I'm feeling lighter. I'm finally feeling like I can breathe. The night is calling. Tension, gonna blow in the breeze. We're rolling downtown. We're grooving to the sound. We're rolling downtown. The weekend's here and it feels so right. I think I'll break the skins out tonight. I'm gonna go out and have a good time. Ain't nothing gonna stop me tonight.
Welcome to the final day of Formnext. As we wrap up the 10th anniversary edition, Formnext News brings you fresh insights, standout innovations, and the moments that shaped this year's show. Here are today's highlights. Thursday evening marked the highlight of Formnext, the awards ceremony. After selecting finalists and counting votes from visitors and the Formnext family, the winners of the 6 categories were announced. Here is one of the winners.
We won with a new revolutionizing technology called volumetric printing, which prints the entire ready objects within seconds as opposed to hours.
The selected winners also receive a cash prize, 5,000 euros in the startup category and 4,000 euros each in the A Ambassador, Design, and Sustainability categories. Congratulations to all the winning teams and projects for their outstanding achievements.
This is a part out of aerospace, an industry that additive manufacturing finds enormous use in. And I'm talking to a specialist right now who is going to tell us all about it. Hi.
Hi.
What really drives the aerospace industry today in terms of additive manufacturing?
So I think all of them are searching for ready-to-use technology with the right capacity, with the right capabilities to be able to manufacture whatever applications they need very fast, efficiently, and costly.
Okay, and which innovations would you need so that aerospace can really take off in regards for additive manufacturing?
The main one will be to print the final part in a 3D printer. But meanwhile, the interim solution is to generate excellent molds that can take composite materials very fast in just a matter of days instead of long durations in the past.
Okay, we have big plans.
At Formnext 2025, the watch and jewelry industry is showcasing how additive manufacturing is reshaping craftsmanship, enabling ultra-fine and complex designs that traditional methods can't achieve, while also highlighting emerging trends in the industry.
There are 2 trends combined. The industry is trying to improve the efficiency of the manufacturing process and the supply chain because of the gold prices, because of the scarcity of the gold. And it's trying to reduce the cost of the labor. It's trying to get into automation and automatic post-processing and minimal post-processing. The additive is struggling to meet those requirements. So the additive solution that will give value in jewelry will have to ease the supply chain of gold and to reduce and automate the processes and post-processes.
The branch sees additive manufacturing as a driver of innovation, combining creativity, precision, sustainability, and personalization. We are excited to see how this will develop in the coming years. Don't miss the final talks on the industry stage today. The keynote, The Value Paradigm, at 12:30 p.m., followed by the after-work talk at 1:10 p.m. with Formnext executives and management. Catch these closing insights before the show wraps up.
Formnext 2025, Day 3. And although Summit Celebration is already over, there's still loads going on. Come check it out. Formnext is all about scanning, prototyping, casting, powdering, processing, and we've seen the entire process chain. But where can you actually have fun here? We'll find out. Wow, this is a big guy. I wonder where he was printed. remove the structures with a chisel. Sometimes when people have been specializing in one area for too long, they say this, that, and the other is not possible. But not here. This is where young innovators make ideas happen. Hi, my name is Syl. Who are you?
Hi, I'm Rudy from
Hi,
Recycling
Rudy.
Fabrik.
Ah, what fabric?
Recycling.
Recycling. Okay, so you do recycling.
Yes, we do recycling.
Okay.
Recycling plastics from 3D printing waste streams and making out of this new 3D printing filament.
Okay, can you show me what you've got?
Yes, 3D printing filament made out of 100% recycled materials.
Okay, 100% recycles. Where do you get them from? What does it do, the filament? Where does it come from?
Directly from our customers. We source the material directly from the customers who can send us their waste, scraps, everything they collected, also empty spools, and we are reusing it into making new 3D printing filament, and it's equal to traditional normal filament you can buy in other shops.
Sounds groovy. What are these?
These are objects to show the wide variety of our color collection. So it's not just brown filament when you recycle material, we also offer gray, ochre, terracotta, red, yellow, so many colors, over 60 or 17 colors we have at the moment,
Okay.
and I cannot count them anymore.
So whatever the customer wants, they approach you with their inquiry and off you go.
Yeah, we can do it.
Sounds good. Thank
Yeah.
you so much.
You're welcome.
Then I will see you around.
Have a nice day.
Bye. We're celebrating 10 years of Formnext this year. The 11th has obviously already started. Make it safe, make it AM. Bye. I wish I could have a bigger boat. Yeah, it's quite decent, but I want an even bigger boat. Now that's more like it. AM, that's where dreams are made of.
Welcome back to the fourth and unfortunately last day of Formnext 2025 here in Frankfurt, here from the exhibition ground floor from Hall 11 D72. And I'm a little bit sad that we will have the last day, but not too sad because we have a lot of highlights for you collected today again. And but maybe before we start into our highlights, maybe we have a short look back the whole week, was full packed with news and information. We learned from Deutsche Bahn how they included thousands of 3D printed parts into their trains. We saw experts here on the stage with product design who discussed how 3D printing can empower designers and engineers to innovate faster and with new customization options. And despite a tough economical time, 3D printing will continue to revolutionize the approach, product design and manufacturing. Yeah, dear viewers and dear guests here at the booth, what was your highlight? Maybe you give a comment on LinkedIn live stream, right next to the live stream. We would love to read that, or you go to Instagram and see one of our clips there, and maybe you give us a thumb up or a comment over there. But now, let's start again into our fair day. And today, as I said again, you can expect a rich program around additive manufacturing expert presentation and a discussion panel today. And now I'm very happy that my sadness is spread here or talked about with my guys here on stage. We don't have a coffee, but it's our morning talks are kind of coffee talks. I would like to have a coffee right now.
Need one.
Yeah, we would need one, but no, I forget. So we have to work with water, and you get the tea for your voice later. So maybe I introduce first my guest here on stage. We have Andrew Elson. He is with 3D Squared. Good to have you here.
Thank you.
Andrew. Chris Needham, he is from Innovate UK. Good to have you here, Chris. And Josh Dugdale, good to have you here, Josh. He's with Additive Manufacturing UK. And you see the red thread between the guests here. Everybody from UK, maybe you heard it again, that UK will be next year's partner country. But let us stay a little bit with the partner country and the exhibition from this year. So maybe, Andrew, looking back as I did with some few words, when you went around the exhibition and what you collected, partners, ideas.
That's okay.
Partners, ideas, thoughts, and new products you want to produce at home.
Yeah, so when I come to this show, I tend to go and look at the smaller companies. I've been doing this for 33 years, and the bigger companies have still got the technologies, and I follow them online. But the interesting thing is done by the startups. So the most interesting one I've seen is on a Danish startup company, and they're actually 3D printing parts into a little canister in the middle. It's got the resin is left around it, and then you take it out, and it's a solid part. It hasn't got any layers, and it's in 30 seconds. So that's like an injection molded part without the tool. That's like, yeah,
that was your highlight. That was award winning, right?
Yeah, that's interesting because there's a couple when I do these things. The last time I came, I saw Foundry Labs from New Zealand. And they won an award, so I thought, oh, I must still be okay at what I do.
And any new partners with Spain? Maybe partnering between UK and Spain, especially in the focus?
I work all over the world, so I've done it for years. So when Sasha asked me to do this, and I'm working with Josh and the guys over there, yeah, it's good. We've had people coming on the booth that are looking for suppliers in the UK for their technologies from Italy. So that's what we need, is working more together.
Now my question was because of the party yesterday, Chris. Did you attend the party? It was all about Spain and the Spain food, and it was not so much Spain music, but, or did I miss the Spain music? I don't know.
I haven't heard anything.
Anything.
and the Spanish food, as I lived in Spain for quite some time, there was like a limited selection of Spanish food. Let's put it that way. Good.
Yeah. Okay.
No, I deny all rumours of me being at that party last night. So we've in terms of the show, we've brought a delegation of very forward-thinking UK SME technology developers. That's why we're over here in Germany for some visits outside of Formnext before we then brought those technologies to Formnext. And what I've particularly enjoyed about this week is the conversations that I've witnessed going on between the technology developers we've brought over and the delegates on the stands and their exhibitions about how, it's what I like about additive manufacturing, how those technologies can bleed together. It's a bit like a melting pot. So robotics and post-processing and how that can complement additive manufacturing. Andrew and I were talking about that kind of hybrid approach. Of just using the right tool for the right job and connecting them. The role that additive, that AI has to play in optimizing processes and how the AM works. And we've got some organisations working on vision systems. So for me, the highlight has been those, it's not just what you see, but it's the discussions between engineers or between supply and demand. How do we solve this problem? We're problem solvers.
We have to talk about the AI aspect a little bit later, because I had Jonathan Rowley yesterday here, and he was very, he had a very clear meaning about using AI. So maybe we talk about that later. But let's bring in Josh. Josh, what have been your highlights here? Or maybe you bring in some new aspects to the round, but feel free.
So I guess our purpose being here this week is to support UK companies who are exhibiting, and I guess there's probably two real highlights. I would say is one, just sort of the number of UK companies and visitors to Formnext. We had a bit of a sort of a gathering on the first evening, and it was great to see so many UK companies come over, even those sort of outside of our sort of immediate circle within AM UK. It was really positive to see, and it sort of sets it up for a good, hopefully a good show in the next 12 months, and we can get more of that here. Get more of that over here to Formnext in the future. So. Yeah, that's probably been my main highlight. I think the other thing that we've obviously been hosting a stand, and I think the constant theme that's coming across with the companies that are exhibiting with us has been the quality of the visitors.
So where is your booth located?
So we're in Hall 12 in row E138.
So upper level or
the lower level?
Lower level.
And yeah, they've constantly been talking about the quality of the visitors and the conversations that they've been having. I think it'd be fair to say a couple of them, they have told me it's been sort of one of the best shows that they've ever done, and they've been absolutely blown away by the conversations that they've been having. So that's for us, that's absolutely fantastic news to hear. And onwards and upwards, hopefully.
Yeah, we had full rows here at the stage whole the week, and the visitors here around the booth, a lot of people. So from the first day, we unfortunately are not so flexible to go around the fair.
That's quite a pity.
Yeah,
but let me ask a complicated. No, I don't know whether it's a complicated question, but after we skip the introduction, just let me ask you one question. So what I've seen here over the last week was pretty much that we have to think more in verticals instead of thinking of AM as an industry. Mm-hmm. So I don't know whether you have seen it as well or heard it in the conversations, because we're always talking, and you mentioned it, the process chain, and I think this is a big achievement that we are already talking about the chain, and not only about we are talking about metal printing machines or post-processing. In standalone, we're talking about the process nowadays, but I think we have to think more in verticals. Is that something you experience as well in the UK, that the AM community is asking for, let's focus more and think what kind of solutions do the verticals need? Is that something that you experience?
So we're now seeing sort of the transition, I guess, from a sort of AM as a sector to actually applications. What applications are in aerospace, defence, energy, oil and gas, healthcare. That's become, there's definitely been a shift over the last 12, 24 months in the UK towards especially seeing how we can further get into those supply chains. Obviously, we've got a UK focus on that, but there's, it's how I'm sure that probably that trend is happening globally.
Cool. And Andrew, you mentioned the combination already when you started. So yesterday I talked to an exhibitor that told me that when they think about going to a fair like Formnext, they no longer think in presenting only themselves. They try to present a process train in a certain vertical or as an option for a certain vertical to experience the same. Or would that be a way like to attract more like customers? Because finally we need to earn money, right?
So I have this thing where the industry's, I've been doing 30 years, all right? I thought we'd be here after 10. So for me, it's been a bit frustrating. And I actually would say to Josh, we need to go, this is going to sound bad, we need to go to non-AM events. You need to go to a science one, a cooking one, an artist one, yeah? Because in the end, I'm an artist, yeah, but I have an engineering mind, and you think differently. And to grow this industry, we have to go, like, especially the machine manufacturers, they've got to go into different areas. And that's, we need to grow a sustainable AM, not up, down,
I think in my perspective, you need both. I think you need both. You have to go to the verticals and to show here the transition from one to the other vertical, so that we can learn from each other. So that aviation can learn how to use AI in maybe we talked about submarines earlier. So what is the connection between printing parts for submarines or for the for aviation industry?
Well, if you go to some of the F1 team, they have partnerships with like Boeing, because in the end, an F1 car, the wings are one way, and in a plane, it's the other way. So they're totally different markets, but and they're good because they talk. And I think the other thing we need to do is we need to educate people better. I actually go into schools now and teach kids because they're going to be the people of the future. And that's what we need to grassroots.
Oh, that's actually a good question for you from the UK, because I had Nayara from Adit yesterday here on stage, and she was talking about what they do in Spain, and finally we discussed a little bit the gap between, I mean, the little kids over the educational level, so we do on a job education, and then we come to the students, and we mainly focus on students, but in my opinion it's far too late, because getting additive attractive should start earlier. What do you think, Chris?
Yeah, so I've been lucky enough to see some great deployments of trying to bring in get people early, and I listened to how many colleagues and friends have acquired Bamboo Lab printers, and how quickly, and others are available, but how quickly their children take to it and explore, and they can do some coding and they can get something to happen, and then they're not just taking the part off or the toy off. They then have that curiosity of wanting to do it differently next time. So I think that is great. I also particularly I get involved in other things that are not just additive manufacturing, but the move in robotics to no code and low code type processing, and that opens it up. I think in conjunction with not just thinking about how can we use additive manufacturing, but start from the output end. What is the product I actually want? And then that, Andrew was talking quite right to me earlier about it's just a tool. Then you can blend the tools together, hybrid or post-processing, etc., to get the outcome you want. But I think that, coupled with getting curious minds and early stage children at an early stage of their education involved, is just going to accelerate the opportunities. You can see the smile on my face as I talk about it. I think we're at an interesting point.
It reminds me of one of my highlights here on stage when I watched our live stream we produced here. It was Dominic, a 14-year-old entrepreneur. He founded his own company. He started 3D printing with 9 years. So he has a big 3D printer in his child room, and so he was on the exhibition and walking around and giving some interview to our camera team. So I very much love this, and that's what I think. What you mean, Art?
Yeah.
I've actually set up a charity where I bought 10 machines and put them in a facility, and the children come to the school. But it's not about just printing. We're buying a machine which will actually create its own filament. So the children bring bottles in, So it's the complete ecosystem. They get 10 bottles, they get a free print. It goes through the process, recycle it. They can make stuff for school, but they can also sell it. So we're creating like little businesses within a school that when they come out, they can actually go straight into business and get on with it.
Yeah.
So
yeah, funny enough, in my hometown, we have now, it was opened like 2 months ago, a little workshop that is designed for young people starting with 5 years old up to 18. They can come there, work on any material they want, from wood, etc. And they bought 10 machines, put it in there, and you can learn how to design them. I mean, in a very easy way, yeah. But then you can print your own stuff and you can take it home free of charge. And this is there was such a run on additive once they saw it. They forgot about the wood, etc., which is kind of sad. But I mean, they were totally into AM, so I totally agree.
I think
let's attract them.
You also need to teach people how to fix the machines.
Yeah,
I've got Bamboo Labs. That's the closest thing to plug and play. But when something goes wrong with it, people are like, "What's caused this?"
Yeah.
So the first 2 lessons when they have the school thing is all of the different technologies. The second lesson was how to level the machine.
Ah, cool.
Because then they understand how it works.
Yeah,
that's great. That's great. Well, I have no particular affiliation with the University of Sheffield, but between two traditional old buildings, there was just an open area concourse. They built a glass atrium, and you go down to a coffee area. Before you get there, the first thing you see is a glass-walled box, and in there. There are robotic solutions. There are a couple of different AM type solutions. There's electronics. You can just go in there, book a slot. If they've got a slot there now, you can start and just go and experiment and play. And there are lab support folks in there to help. I so wish I had that when I was going through my training. Fantastic.
Yeah.
Yeah. Maybe let's switch a little bit the focus to the future. To next year's exhibition when UK will be partner country. Josh, what do you intend to, or how do you intend to deepen the collaboration with the other companies, with the other countries here, the European countries, maybe the countries from abroad? We have very international exhibitors here and very international visitors.
Mm-hmm. So, I mean, we've obviously been collecting, if you like, content in preparation for next year. So we'll hopefully be doing a big promotional push for UK companies to attend. I certainly know we as AM UK, we're part of the AM Europe initiative. So that's us partnering with other European equivalents around. So, we're very friendly with, you've mentioned Niada from Adimat, but also VDMA, SwissMem. Yeah, so we'll be working hopefully within that forum as well, to hoping sort of push out the messaging through all our partner networks that we're engaged with.
Mm-hmm.
So, but let's talk a few minutes about UK, because that would really be interesting. We talked so much about Spain this week, and so, but have a little outlook. I mean, what is the current status of AM? If we can sum up this in 2 or 3 sentences. So, where is AM standing? What are you heading for? What is the current state? Because we experience here a lot of consolidation. I don't know whether this happens in the UK as well, and kind of what is the outcome and what is the next step? Because what I really liked about this week, where we're talking so much about profitability, and I studied economics, sorry for that, but I really love that thought. So how is UK doing?
So UK, I mean, it'd be a lie to say it hasn't been a tough economic environment for the last 12 months, but but also AM companies are doing really well. I'm talking to a lot of members who are producing parts, and they are constantly saying how busy they are. And we're hoping to see that will start to turn into, more purchasing of capital equipment, investment in this, of the infrastructure. There's definitely now a focus on how do we go from these early stage companies that are now reaching that age of about 6, 7, 8, 9, 10 years old, who are in the AM space, and how do we help them scale up and grow so that they can, service a wider range of industries. Obviously, we've seen a massive growth in defence in the last 12 months, and that's massively helped spur AM on and adoption in the UK. But we're starting to see, more growth within, the traditional sectors where you might say aerospace, medical, oil and gas space. The space has actually been a real area of growth as well. So despite the sort of tough economic headwind in the last 12 months, I think people are starting to look forward with a bit of positivity.
Very good.
And I think, hopefully next year, obviously we run an exhibition which is focused on the UK, and I can tell you that it's starting to. People are starting to sort of pay attention. We're seeing a lot of pre-registrations. The floor space is filling up, which sort of indicates that actually people are starting to feel positive. Around the industry.
Absolutely.
Yeah.
Thank you so much.
Yeah, Chris, looking ahead to Formnext 2026, what can we expect from UK from your perspective? What do you see bringing here to Frankfurt?
So I sit in the innovation space. So I work for Innovate UK, which is the UK government's innovation agency, and I like the space that's sort of between early stage research and getting things over the hill into commercialization and reality. So I love working in that space. What I think the UK is great at, and we won't be alone, other nations I'm sure are strong in this as well, is that kind of collaboration approach. So I'm lucky enough to work on a number of projects that bring together large and small businesses, technology developers and manufacturers. So people who have an issue and people who have a solution or can develop a solution. And also we have a number of projects that we support that are involved cross sectors, across manufacturing sector, and some brilliant conversations that I get to witness where aerospace, automotive, medical, all of which are relevant to additive manufacturing, of course, are sharing their challenges, their issues, their solutions. They're often all working on roughly the same thing, just under a different system name. So those collaborations, and that's why we brought a group over to Formnext this year. What I look forward to doing is seeing how we can bleed that into the stand, into the makeup, into the week and the program, and hopefully make it less about just the 4 days at Formnext, but also the build up to that, and then what can happen afterwards. Now we can build on the success of this year's collaboration with Spain, etc. So lots of opportunity. I don't know the answer, but some of those we will do.
Mm-hmm. Perfect. Andrew, what are you looking forward to when you think about next year?
We're actually working with Josh quite a bit, and people have tried to do this in the UK for 30 years. There's normally a student, they get a job, it drops. So I actually sat with them last time with all the people that are on their committee. This guy has really pushed it. This is the first time it's moving forward, right? And then the people that you've got on the board, they're all passionate about 3D printing. And you've got them in every country. So I think for Europe and the UK, it's a really positive move. I actually just said, thanks for actually making it work. We just need more people to push it.
Absolutely.
But push it in the correct direction.
And we will see them next year again here.
Yeah.
Here on stage and on the fairground as well. Yeah, we have a little bit time left. Maybe I want to give you some highlights we produced for you. We are a little bit late, but maybe please say if you have enough time to show the highlights. Fabian, yeah?
Formnext 2025, day 3. And although Summit celebration is already over, there's still loads going on. Come check it out. Formnext is all about scanning, prototyping, casting, powdering, processing, and we've seen the entire process chain. But where can you actually have fun here? We'll find out. Wow, this is a big guy. I wonder where he was printed. Remove the structures with a chisel.
So that brings us a little bit good mood, I think, for the last day of the show. I thank you very much for being with us here, and I wish you a good last day. And I'm very happy to see you here on stage next year, and then we talk again what UK will bring to Formnext 2026. Thank you very much. Thank you, Sven, for being with us. Dear guests here at the stage, dear viewers at home at the screens, thank you very much for joining us. And we will have, after a short commercial break, we will present the next expert insight, bringing even another innovation here to the stage. Stay tuned.
10 years Formnext in Frankfurt. That means 10 years of innovation at Renishaw and 10 years increasing productivity in AM systems. If we have a look at it, at the journey, we talk about high efficiency quad laser module, then Tempus technology, Libertas, long life filtration system, just to name some of these milestones which make AM technology today extremely productive. Let's have a closer look to it. Hey Chris, how are you doing?
Rhino, I'm good.
Great first day at the show.
Brilliant show, fantastic. Just what we've been looking forward to.
Excellent. This is here really Renishaw at its best. We have a whole process, additive manufacturing, milling with our partners from the company Chiron, and final inspection with our latest and new Equator X. But what I particularly like is our digital workflow with our partners from Siemens, where we design the part, we design the process, and then we implement it in one go into the factory. That's really fabulous. What about the 500Q Ultra? What's special about it?
So the Renishaw 500Q Ultra system is really highly productive. And there's a number of reasons for that. Number one is that it's got 4 lasers within a very, very small, compact footprint, which is really important for some of our high production users. It also then leverages Tempus technology. Tempus technology is patented process from Renishaw, which means the laser actually operates on 2 different layers simultaneously while the machine is wiping. So effectively, powder is being spread constantly while the lasers are still firing. This is an algorithm we've developed, patented, and is being implemented by many of our largest serial production customers.
Excellent, thank you very much.
Thanks, Rainer.
That was not it yet. We're looking here at our latest milestone in increasing the productivity of our systems. Hi, Luis. What is it about with Libertas?
So the first thing to say about Libertas is that it is a software product. So for our existing RenAM 500 customers, there's no additional hardware required. And as the name suggests, Libertas gives those customers the freedom to dynamically optimize their laser parameters across all regions of a geometry. And this is maximizing the quality that our customers have come to expect from Renishaw.
So on these parts we're seeing here, what kind of reduction of supports we're looking at?
Yes, so what this freedom means is that users and customers can basically now print with vastly reduced supports. So all of this fewer supports means that we are saving on material, but we're also improving the surface finish of the parts. And the reduction in supports also is a benefit for post-processing. Yeah. So we're saving time taking those parts off, which is having a positive impact on productivity and the environment. So these are a range of parts from different industries. We've got some dental, medical, aerospace, consumer electronics. And what we've got is a range of savings from Libertas. So from 60%, 80, 96, and this part has got a 97% reduction in support material.
And there are also builds now. We can build with Libertas. We couldn't even build without Libertas.
Absolutely. So, and this particular one where we've got 1 row of parts, that's because it wasn't possible to build it in a stack with the supports. Impossible to get the heat out. Once we apply Libertas, then we can build a whole stack. So this technology really opens up the applications for our customers to print parts that maybe weren't possible to print before.
So I think it's fair to say we maintain the market leader in ratio productivity to footprint of our systems even more with Libertas.
Absolutely. It's in addition to the Tempus technology that we introduced a couple of years ago. Now we've got Libertas, all aimed at productivity.
Excellent. Thank you very much.
No problem.
Pleasure,
Thanks,
as
Reinhard.
always. We had a fabulous first day at Formnext 2025, and we truly enjoy our journey through innovation. Thank you very much.
Welcome back to Formnext 2025 and welcome back to our next highlight here on stage in Hall 11D72. We are very happy to have you here in our live stream and here at our stage in the booth. So this year's Formnext, you know, saw tons of innovations here on our live stream and on the fairground. Our next speaker is going to add again one more highlight with her keynote presentation. I'm very happy to have Nicole Kläger with me. Nicole, come, join me on stage. Nicole is CTO of Salea AG, and she will show a pinch of salt, a dash of innovation, how she will unlock the materials freedom with indirect AM. The stage is yours, Nicole.
Thanks a lot for the kind innovation, and super happy to be here and explain you a bit more on how we tackle 3D printing of challenging materials. So maybe to give you a quick overview of my talk, I will start with why indirect additive manufacturing is in general an interesting tool to go for, and then how we tackled the challenge of printing sodium chloride as a sacrificial material, and finally come a bit to a case study on how we use this indirect additive manufacturing at Salea. So maybe I would like to start with a question. Who of you would have liked to print a material at some stage but wasn't able to find the material that you wanted to print? Yeah, so perfect. You're in very good, community. It's one of the major reasons why additive manufacturing is not being used more broadly in companies, and this challenge is actually increasing as time passes. Now, there have been different approaches on how to circumvent that challenge, and one of them is indirect additive manufacturing. One way that might be most familiar to people from the jewelry industry is templating. So we print a positive form or shape with a wax pattern, cast gypsum around that, melt the wax out, and finally create a cavity where the metal can be casted, and finally the gypsum is removed. So this is used in academic research, but also in industry, as I mentioned before, for jewelry manufacturing. While that is a very convenient approach, it's also several steps, and with every step there is the risk of including defects, for which reason more and more people switch to a two-step approach where the molds are directly created by additive manufacturing, as for example sand cores made by X1, which are then shaken out after the casting of an aluminium part. That's also nice, but sand, there is often, with the shaking out, there is grains being left in the part, which can cause problems. And some materials, such as, for example, magnesium, will also react with the salt and with the sand, and that's not an option. And for that reason, we looked for an alternative which doesn't react with materials such as magnesium and also can be easily washed out. So we came to the conclusion that sodium chloride, is actually a super cool material for a lost core or a lost mold. Now, how do you print sodium chloride? We started off with an easy process. For people of you who work in manufacturing also outside of 3D printing, you might be familiar with the process called salt leaching. It's a process where salt is simply compacted and then cast with the desired material, such as, for example, magnesium metal, and finally we just wash out the salt to create a porosity. Now, as you all know, if you just compact salt particles, it's very difficult to control the porosity, and that's why we usually had to additive manufacturing. Now, in our case, we started printing sodium chloride with direct ink writing. super easy process to start with. We just mixed the salt particle with a paraffin oil, added some surfactants to have the particles nicely dispersed, and printed them into grid-like lattice structures. That all worked really well, so we did a proof of concept with magnesium. We could cast the magnesium, and what was also super nice is as the infiltrate, we could also machine it without destroying the pores, and finally just wash out the salt in a sodium hydroxide solution to create the porous magnesium body. So that was really nice for academic research, but also direct ink writing is somehow difficult to scale when it comes to commercial solutions. And for that reason, we switched to light-based printing. Similar concept, we just replaced the paraffin oil by a cross-linkable monomer and then cured it with light into 3D structures. Now, as you might have seen, or as I mentioned before, we added a surfactant, and what was also really convenient is that the surfactant degrades into sodium sulfate. And you might have by chance the phase diagram of sodium chloride and sodium sulfate in your head, maybe. So these two salts have an eutectic composition, which decreases the melting point and helps us in sintering to make a dense surface on the parts. Now, that was all really nice, but we were continuously approached by the food industry, and monomers and food is tricky, and also from a cost perspective, it didn't really work out. So we are switching the printing technology. Oh, actually, sorry, I missed that. So we managed to show a broad range of materials that could be infiltrated, cast, and also for composite wrapped around the salt cores to shape a wide range of different materials, all the way from light metals such as magnesium or aluminum to composites and even food. And as I started before quickly, we were approached more and more by the food industry asking us if we can shape materials which are difficult to print in the food space. With the whole monomers, that didn't really work out, and the monomers were also from a food perspective, but also from a price perspective, for which reason we changed the technology again to binder jetting. Now, I cannot go into the depth on how we do that exactly, but it brings us the benefits that we can decrease the costs drastically because we don't use monomers anymore. We have a lot less contaminations, again, because we don't need monomers, which can be contaminated with heavy metals. And finally, also the ecological footprint is drastically reduced. Now, that's how kind of the way on how we got to the whole process, on how we used salt printing to shape different materials. But what do we actually use it for? Where does the benefit come from? And for that, I would like to dive a bit deeper into what we do at Solea. So to start off with a bit of background, as you might know, livestock farming puts a very heavy burden on our ecosystem and on our planet. Just to pick out one of these numbers, 77% of the agricultural land is actually used to grow animals and to grow the food that these animals need. And that should already show that we have a problem, especially as the demand for meat is further increasing. Luckily, there are plant-based alternatives, but the consumer acceptance of those is limited, and also the sales are stagnating, mainly because the taste and the texture is just not what we expect from meat. Now, the good thing is that there is globally a lot of companies working on a solution, so-called cultivated meat. For those of you who are not familiar with cultivated meat, it all starts with a small biopsy of cells from an animal, such as a cow. And then the fastest growing cells are selected, placed in a big tank, which looks a bit like a beer brewing tank called bioreactor. And in this tank, the cells rapidly develop and proliferate, so they multiply, and we end up with a big soup of cells. These cells can be harvested and further processed into products such as chicken nuggets or fish balls. While that's all really good, it's still very hard to make a whole cut, so a steak or a fillet, because the cells don't spontaneously grow into a big muscle, but they need something to hold on to grow together into muscle fibers. And that's exactly why we founded Solea. So with Solea, we make porous protein grids where the cells can grow on, hold on to, and grow into a whole steak. I'll show you some pictures afterwards. We're using the process, as I mentioned before, to make these protein structures. It's very difficult to print the structures directly with the right texture. So we use salt templates, which are cast with a protein solution. We gel the proteins, and then we wash out the salt to create the nicely controlled protein lattices. That comes with two major benefits. So for one, we can use the full geometric flexibility of additive manufacturing, and can control the surface or the porosity and the surface area really tightly. And that's important because the cells, they need to have a lot of surface area to hold on to. And at the same time, we need to maximize the flow through the structure to get enough nutrients to the cells. And on the other side, we don't need to put boundaries on the material properties for 3D printing, because we can simply cast it and make sure that we have the right texture and the right nutritional profile on our scaffolds. So we actually wanted to make sure or check if our hypothesis is right, if we can really maximize flow through our scaffolds with that process, and at the same time maximize surface area. So we, together with CAD/FEM, we run simulations, and we started off by just making computer-generated gyrate models. On the top, you see an isotropic gyrate with a unit size of about 1.5 millimeters. We compared that to an elongated gyrate, which was stretched at different ratios, and to a random porous sponge, which also has the pores of 1.5 millimeter, just to make it comparable. As you see on the two graphs, already by making a gyrate instead of a random porous sponge, we can drastically reduce the shear stresses at the surface of our scaffolds, which is important because the cells, I mean, they can hold on tight, but not that tight, so we don't want to wash them away. And also the pressure loss. If you think about having to flush a thick cut, we want to have minimal pressure loss, that we don't need to put a lot of pressure on the part while we feed the cells. Now we can even make that better if we slightly elongate it. We found that with a factor of 3, we already reduce pressure loss and shear stresses quite a bit, and that's also where we, or what we are aiming for now, an aspect ratio of 1:3. Now, we went even a step further. We wanted to show that the structures we generate are comparable to the computer models that we made before, or even better. So we run micro-CT analysis. We regenerated the whole scaffold in a digital model, cut a piece out, and ran the whole CFD simulation again on that computer or micro-CT regenerated model. And what we found was really, really interesting. So as you can maybe see, yeah, hopefully on the pictures, the scaffold struts, they are not dense, but they're slightly porous from the processing, and that also helps us with the texture, but also with the flow. So you see on the graph, on the y-axis, the pressure loss again, on the x-axis, the surface to volume ratio, and the part where we actually want to be is the bottom right corner, because there we have maximum surface area and minimal pressure loss, so we can feed the cells really well, and they have a lot of surface area to grab onto. Now, if we start at the gyrate of 1.5 millimeter unit size isotropic, we saw before that by making it anisotropic, we can already reduce the pressure drop a lot. And now, because we integrate the hierarchical porosity, or the small pores, into the strut, we can also drastically increase the surface to volume ratio, and thus get into the zone, which is very interesting for us to grow a lot of cells. So in numbers, it's about a 3.5 higher surface area and the 22 times smaller pressure drop if we compare it to a random porous sponge. Now we wanted to show again that our hypothesis is really right, that the cells grow really well. So that becomes a bit biological. I hope you stay up with me also on a Friday morning. As you can see, the cells grow really well. So we cultured a model cell line. It's a mouse muscle cell line on the cells, and compare that also to a relevant cell line, a beef muscle cells. And everything that is blue are the cells, so we colored them in that you can actually see them. And on the graph, you see that the cells also grow over a time of more than a week. Now, I told you before, the cell part was the one thing that is important for us, the texture is the other. So we ran tasting on the scaffolds themselves, so no cells in them yet. And as you can see from the textural properties, hardness and springiness, we get very close to what we would expect from a beef cut. And also in a tasting that we did, we could show that it has a chewy texture. It's kind of experienced as fibrous. That comes from the gyrate lattice structure. What might be a bit funny is that it was described as being corporate. That's actually really good for us, because we don't want the scaffold to have any taste, because the taste comes afterwards from the cells. So maybe just to wrap up quickly on the company side, we are a team of about 8 FTE at the moment, and some students and interns that are helping us, otherwise we wouldn't be able to achieve everything I showed you so far. We're running currently pilot projects around the globe, and closed the first pre-seed round of 2.2 million September last year, and we'll open a round again beginning of next year to hopefully continue our journey on cultivated meat. So I hope I could give you a bit of an insight of what we do at Salea, and how indirect additive manufacturing is beneficial for the industry, and maybe it also triggers some ideas for projects that you have in your own companies or projects. Thanks a lot.
Well, Nicole, thank you very much for your presentation. Stay with me, we have a little bit time left, and so that gives me room for one or the other question for you. So you mentioned that the food industry has contacted you early. When can we expect to have food like this in our supermarkets?
That will probably take a while. So cultivated meat is a so-called novel food, so it needs to undergo special approval from the government, which is different to, for example, yogurt, which you can just sell in the streets tomorrow, as long as you have like hygiene stuff in place. So it will probably take 5 years. In general, cultivated meat can be already purchased in countries like Singapore or some states in the US, but not yet on our scaffolds, unfortunately.
What drives you personally to get into this topic? You put in, everybody can see it, a lot of energy, and you're very much concerned about getting it, on the road. But why? What is your goal? What drives you forward?
I think it's different things. I think we really need an alternative for conventional meat if we want to continuously feed the world with good proteins. So I think, like from a product perspective, there's really a big need to find a good solution. Personally, I think it's also a really cool place to be at the interface of engineering, material science, biology, sustainability. So I think there is a lot that can be done by combining different expertise, and also seeing a whole ecosystem grow, probably similar to 3D printing a couple of years back, seeing how it develops and what can be reached if everyone pulls on the same string is really empowering. Yeah.
Mm-hmm. Could it be that, are you working on not just trying to reproduce a meat, a part of an animal, but when your findings in kind of research, and you find out that you can create something entirely new. It's not a fruit, it's not a meat, it's not a bread, it's kind of a totally new kind of food, or a new kind of digesting proteins.
Yeah, it's always a question that we get, right? If you really want to compete with meat, or produce something which will always be compared by the consumer, or if it's not better to just make a new category where no one compares. I think in general people are lazy, so we are used to making meat recipes or meat foods, and maybe on a Saturday evening, if we have time, we're experimenting with different protein resources or sources. But on a Wednesday evening after work, we just want to have a quick meal and we grab whatever is on the shelf. So I recently heard a number that we spend about 1.3 seconds in front of a shelf before we decide what we grab. So I think there it's important that consumers have an alternative, but they feel familiar with what they have and they can use their recipes for a fast adoption. Yeah.
So the goal is to have an answer to convenient food.
Yeah, convenience food, or at least something that that people know that they can quickly integrate into their everyday and not just on special occasions.
Are producing proteins for, let's say, people who starve maybe, or there is a crisis somewhere in the world. That could be an answer as well. It shouldn't be a nice steak. It could be some food, some protein you bring to people who suffer.
Yeah, absolutely. I think that's the overall goal of the industry as well. But similar to 3D printing, right? Prices are just too high at the moment. So you start off with kind of the high-end applications with the goal for penetrating into lower cost markets and obviously feed the world at some point, or at least part of the world. The meat market is massive, so I don't think we're going to replace it fully, but at least cover the increase that is expected over next years.
Yeah, okay. Now, as Formnext is all about transferring ideas from the one to the other industry sector, and when I understood you in the beginning of your presentation, right, you are open for for challenges from the industry, and you're not focused on just this one topic. So when anyone from our live stream or here at our stage want to have kind of partnering or want to bring their problems to you, what would be the process? Like if I contacted you for support, how would it work?
I think it's very easy. As we said, we're a small company, so we don't have a huge like secretary, whatever. So it's very easy. You just type in nicole.kleger at soliop.ch and the email will end up with me. So yeah, we are super open for new challenges. We are currently also exploring into the field of cores, for example, for casting or injection molding, or also composites. I think there is a lot to be done and a lot of opportunities there as well. But as I mentioned, there is a lot of difficult materials to shape. And if anyone has a challenge on that end, we are super happy to partner up and to dive into.
Okay, so make sure that you will contact Nicole on the last day of this exhibition. One personal question: what are you going to do today? How to make use of the last Formnext day?
Yeah, so I think it's, again, meeting with all the people of the ecosystem. I think it's a great opportunity to have everyone in one place, to reconnect, to have a coffee together, brainstorm about projects. So we'll for sure spend some time on visiting everyone at the Formnext. It was a really amazing opportunity, as every year.
Okay, perfect. I wish you a lot of luck with that and lots of new challenges for you and your company. Thank you very much for being with us.
Thanks
and a round of applause for Nicole, please. Thanks. Yeah, dear visitors, dear viewers at home at the screens, maybe I want to give you a short reminder of where you can watch this live stream when its live is finished. So the recordings are to be found at the Formnext Media Library. You can go there and find it every time you need after the exhibition. So scroll through these year's recordings or the last year's recordings. You will find them all there. We would be totally happy when you're sitting at the live stream or maybe watching via LinkedIn. If you give us the one or the other comment there in LinkedIn, we would be totally happy to get your remarks there. So make sure that you stay in contact with us, and here at the booth, make sure to make use of the last day of Formnext today. Yeah, after a short commercial break, we will even see more highlights from our exhibitors here. And on the stage, we will welcome our next expert insight presentation. And again, it has something to do with food. Even it inspired me to think about food because it will bring us into the world of cremini, shiitake and other mushrooms. So stay tuned for this one as well. We see you.
We're here at the FiberSeek booth where we are going to be exploring how fiber 3D printing is evolving. Let us deep dive into how FiberSeek is empowering engineers to build, to experiment, as well as to evolve.
At FiberSeek, we're bringing the world's first consumer 3D printer that prints continuous carbon fiber. So which means it gives desktop printing a metal grade strength, so it's not restricted to like toys, but like functional parts and use parts. You know, for engineers or like even makers, right, when you think about printing strong parts, you automatically think about metal. But between metal and plastic, there's such a thing called composites. And with this new product, you can print composite parts at home, at the office, and it's affordable to every single engineer. Now we're releasing this power to like everyone, to every engineer, to every maker. So I think it's gonna bring a lot of impact to the whole manufacturing industry. More unique is at a price point of like 2,000 euros, and you can print a continuous carbon fiber, which was once like tens of thousands of dollars. The machines are also live on Kickstarter, so it's the best time to get them with the lowest price and with a lot of like packaging giveaways. So please like stay tuned.
There you have it. If you would like to explore the world's first consumer continuous carbon 3D printer, then head over to the FiberSeek's stand right here at Formnext 2025, or better still, visit their website.
Come visit Formnext, there's loads to see. Paris, the city of love. Formnext, the trade fair of love for additive manufacturing. You might have thought AM is all about big machines and raw materials, but it can do glam as well. We're here at Ledger's, let's see how they can glam me up. Celebrating 10 years of Formnext this year. The 11th has obviously already started. Make it safe, make it AM. Bye.
Welcome back to Formnext 2025 and welcome back here to our live stream from Industry Stage in Hall 11. Yeah, I'm not sure how it's for you, but in the past few years I discovered a new hobby, let's say. I find relaxation going out into the woods and collecting some mushrooms and even if I don't find an edible one, I take a picture and then it fits good. I have some success. Our next speaker, he will connect my personal passion with the professional world of additive manufacturing, what brings us together here. And in his presentation, he will take us into the fascinating intersection of biology and additive manufacturing with his talk, 3D printing of mushroom mycelium. Dr. Sascha Peters. I'm happy to have you here.
Thank you on stage. Thank you for the warm words.
Sascha is CEO of Odd Innovation, and I'm very curious what you brought with you in terms of mushroom printing or whatever. We will see.
Yeah.
The stage is yours.
Thank you so much. Maybe you have heard about that mushrooms are used to produce materials from. That is invented by a company from the US, Ecovative. It's called about 20 years ago. So they started producing packaging, biocircular packaging, biodegradable packaging from it. Depends on the mycelium you use. You can create soft materials, even leather is done by this with this technology, biodegradable, completely 100% natural. It could be soft and foamy. That's a project done by researchers in Berlin. It could be strong and stiff for furniture, for seating, but also for stones. That's what we talked about. Building, probably you heard about that at MoMA in Brooklyn. There was a pavilion done some couple of years ago. Quite interesting to see that mycelium could be work in construction. But what is mycelium all about? What we know as a mushroom is just the fruit body. What you see underground is the mycelium. Normally the mushroom needs to throw out spores to find new food. The spores go onto the ground and then starts to grow into the ground, finding sugars, lignin or hemicellulose, what gives him the possibility to grow into the ground. What it makes so strong and stiff at the end of the day is that when mycelium, so the whole thing is called mycelium, these hyphae, these fibers meet each other. They are not growing up or down, they grow through each other. So you see a strong, let's say, a strong network of material created by that natural fibers. When you try to start to work with it in the lab, you need, for example, agar-agar, some spores on it to let them grow, hemp fibers, something with cellulose inside, and after 3 or 4 days, let them grow into a mold, and then you create a block, a round block, whatever. Ecovative is doing this for quite a long time now. They let the mycelium grow into PLA molds. This is their factory. You see that you need temperature in between, let's say, 22 or 25 degrees. You don't need light, you don't need energy. And after 4 days, you're going to dry. You dry the material, and after it's completely dry, up to higher than 60 degrees, let's say, then the mushroom dies. It's not going to grow again. So there are quite a lot of designers working with mycelium nowadays. Netherlands designer streAM did a helmet, bicycle helmet, which you can throw away when you after you have had a crash, because it's biodegradable. Car industry is jumping into. EDAC did a piece we had on display on a fair in Sweden right now, where they combine injection molded pieces with mycelium. When you press the mycelium, you could have really strong and stiff boards. When you reinforce it with natural fibers, they could even stronger. That's what KIT is doing in Singapore. And then they test it for construction. You see that's inside the building. The wall on the other side is outside, and they are quite strong conditions for materials to withstand weather. Mogu, Italian company, is doing this for flooring. They coat the material with plastics. Of course, you need a stretch-resistant surface for flooring. So it's not 100% natural, it's only 90%, but they are on the way to the right point. It's about sound absorption. That's what they did. Designers started to work with lampshades. Jonas Edwards, by the way, more than 10 years ago, he did this piece, and now he starts to think about, okay, I can use wooden textile and let the material, the mycelium, grow into. What a nice piece is that. More art, design, but really interesting to see. The first who started with 3D printing was Eric Klarenbeck, a Dutch designer. He printed PLA and then let the mushroom grow into. That's, by the way, a piece that ends at MoMA in New York. Super successful design. Another way of thinking about 3D printing is print with clay and let the mushroom grow into. That's a piece Studio Blast did in London, or TU Graz did it in Austria. We have a video. I have a video with me to show you what complex conditions you need to let the mycelium grow. Can you start the video, or do I need to? No, it's not. If it's not, okay, it's okay. So they start to mix the clay. It's, by the way, a VASP printer from that Italian company. So that's the normal workshop condition, yeah? And then you need to sterilize the material. So now it's going into the clean room area, which is, so you need quite tough circumstances. Get all the bacteria out of the material, otherwise you don't even see the difference between mushroom and mold. By the way, that's, so they call it vaccination of the material with mushroom, and then you need 3 to 4 days to let the mushroom grow, the mycelium grow. The white coated piece is completely filled with mycelium. Okay. What they also find out is that in the cell wall of mycelium that that's what you also could find in insects, the hard shelf of insects. One mushroom which consists of chitin and cellulose, which is the only mushroom which doing so, is called omicete. That's what Spanish designer in Singapore used to develop a material a couple of years ago and print the material with cellulose, chitin, and the mushroom inside. First, I thought it's a mushroom inside, but he said it's bio-inspired by the mushroom. So probably the mushroom is not inside anymore, but the chitin is inside. And it has a crystallized phase, which he is able to bring in between the cellulose fibers to print super strong and stiff parts like a blade. This blade we got from him, which is now exhibited in an exhibition we did for Futurium in Berlin. So if you ever have the chance to come there, it's downstairs in the lab, this blade. We're so proud because it's just one single piece they did. Super easy to print, super cheap to print, super low weight for a blade like this, and biodegradable. What he also did is a column for the 10th anniversary of the Singapore University of Technology and Design a couple of years ago. So now quite a lot of researchers around the world and also in Germany are jumping now into printing with the material mycelium is producing, like the chitin. In that case, Fraunhofer IPA in Stuttgart is using the chitin and carboxymethylcellulose as a biobinder. We had this on display last week on an exhibition we did for a Swedish fair. And then we found guys in Dresden, they start to think about printing wood, and they use this carboxymethylcellulose as a binder, no mushroom inside, but they had quite an interesting printer developed. The project was called Edwood. And now we are using that printer together with Fraunhofer EWU from Dresden for a project called Mycoustics to print the housing of loudspeakers with acoustic absorbing and acoustic reflecting abilities. Probably you have heard about a transmission line loudspeaker. This loudspeaker has super interesting sound creation because inside the loudspeaker it gets off the high frequencies of the sound and let only go through the lower frequencies, the bass go through, and that's exactly what we try to do. So with a mushroom or mycelium like this, let's say the champignon, you have these fluffy abilities to absorb the sound, and when you have other mushroom like reishi, you could create hard and sound reflecting surfaces, and this in one step. The researchers in Dresden found out when they play a little bit with temperature and humidity, they can create different surfaces in one print. And that's what they play now with that. So they start with a receipt of using lemon mushroom. Xanthangum, by the way, is the biobinder, but they can also play a little bit with the ingredients in that receipt. We printed live on a trade show in Cologne in May this year with that printer we got from the Edwood guys from Dresden. That's the The loudspeaker we want to print without mushroom because that's not possible on a trade show because of the hygienic situation. Then we see when you print with a paste, there is liquid inside, and you have to find a solution for and react on shrinkage. So what they did in Dresden is to fill in spacer rods into the printing process, and finally are now able to print the whole piece with wood fiber length of 3 millimeters. This is now exhibited at Fraunhofer, at the Fraunhofer stand right over there. And the next step is to bring the mushroom inside. That would be, I think, done in the next month. I hope to have this special sound absorbing and sound reflecting surfaces, and then of course they will measure the piece and have the right answers for the next step to bring this product into the market. What we also find in Berlin is at the Technical University, they print with another receipt. They print with a mushroom called Sunderschwamm in German. That's the international name. Rapeseed straw and sodium alginate. And they played a little bit with the drying process. So they dried at 70 degrees, they dried at 150 degrees, and they use freeze drying. So maybe that's something you could also play with. Freeze drying has lower shrinkage in the geometries they use. What they also played with is they found out how to create a foil or a paper just with mushrooms, with mycelium. They call it fungal mycelium mats. And because it's like a paper, they want to enhance the mechanical properties by printing on lines with PHB or PLA, these two biopolymers. And they had quite some interesting results with papers and foils with that high mechanical properties. So that's the last example I want to show you. Researchers at EMPA in Zurich found out a way to produce a fungi battery. How can a mushroom create a battery? They work with yeast fungus, that's the yeast fungus, releasing free electrons while growing. As a partner with complemented a white rot fungus that is producing special enzymes to catch the free electrons. So you can close a loop for electricity to get energy from, to have electricity. That's what they do. So they print first these two sorts of mushrooms in an ink, then dry the mushrooms, then the electrons are still there, and when you want to activate it, you just need water and nutrients to let the mushrooms grow again. Then you close the loop, the energy is coming out, and after you finish whatever you do in agriculture, for example, to run a sensor, whatever you use the battery for, the battery is biodegradable, and then it could be left in nature. The researcher, by the way, is the Swedish guy, Gustav Nyström, who also came to our exhibition in Sweden 3 years ago. So these are his hands, because the image was oriented in another way. Yeah. Thanks for listening to me. Now 1 minute only left, and I will answer your questions if you have any. Thanks a lot.
Yeah, first a round of applause for Sascha. So thank you very much. That's really great examples you brought with you. So we have a little bit time left, so we can have a short dive into your topics. First of all, I want to better understand your role, your business model. So the examples were extraordinary, and I think the audience is the same. Has the same opinion. It's really cool, and each one of the examples one could step into deeper. But maybe coming to your role, you bring all these partners together. You do not print the products. What is? Please describe your role in this.
So we are a future agency in Berlin, and we are always looking for new material development to predict the future of products. In the last, let's say, 5-6 years, we found out that there's a lot of things going on at the border between biology and technology and engineering, because they all find out that with the materials we use nowadays, this could be not the future. So with all the plastics that could be exchanged to biocircular materials. And that is one example we found out. So of course, we have a huge network.
Mm-hmm. But you would offer your services as consulting?
Yeah, we do consulting.
Mm-hmm.
We bring people together. We have a large network, so people come to us and say, do you know anyone who could work with my material that I am working with or I developed? Of course, we show innovation on shows, trade shows, but also in science centers like the Futurium in Berlin. And sometimes we also develop our own material. So my colleague Diana, she is really an expert into mushrooms, which probably brought us also to the Fraunhofer guys, because they read a lot of what we did with mushrooms in the past.
I see.
With mycelium in the past.
Let's just hit one topic, the scale up. I think what you showed, there are some processes. Some looked really like industrial scale in the beginning, but some, seemed to, you have to clean it, you said, and you have to have a very lot of steps you have to follow. But what about the scale up? How easy is it to get with printing mushrooms or creating mushroom products to get into industrial scale?
Yeah. So quite some companies did it in the past, and I think they were slower than other companies. Let's say it like this. To be honest,
it's a challenge.
It's not,
right?
because it's not like industrial manufacturing. You have a huge manufacturing facility, and then you have millions of square meters.
Can you name a hurdle? Which hurdle is there? Maybe is there a red thread of hurdle in between all the examples you showed? What's always a problem we should overcome?
Now, with mushrooms, you have to work quite clean and hygienic. So that's the first thing, and then it's not a continuous process. You have to let them grow 4 days, then you have to dry them 4 days.
The batch
then you open and close and clean, and so it's not that easy. But the result is quite easy to understand for nature.
And very impressive. Very impressive, let me add. Yeah.
So different generation of materials. We are now stepping in, and we have to understand how these materials work. So it's really complex to answer this question.
Yeah, I know. You will have a last day of Formnext today. What your personal thoughts? What are you going to do? You look to the colleagues from the Fraunhofer. Maybe
of course. I will go there after.
Yeah.
But also, I'm looking for a piece, printing wheels, because we are also into other product groups, and a wheel, let's say, is something also of the past, because it's not biodegradable and you have abrasion of the material which ends in nature. So we have to find solution for this, and I'm looking exactly for these solutions. Probably they are some in nature, and I wanted to know if you have some at Formnext. A 3D printed wheel for me would be fantastic to find.
Okay, shout out to all the exhibitors and visitors here, or maybe have a look at our stream. There might be the one or the other wheel. I saw some boats there, but I can't remember a wheel.
A wheel. I'm looking for wheels.
So, please, dear audience, help Sascha to find his goal here on Formnext. Thank you very much for having you with us, and a round of applause for you.
Yeah, thank you. Thanks.
Yeah, thank you very much for watching our live stream. And after a short commercial break, we will see the next program highlight here on stage, the supply chain panel hosted by my colleague Sven Krause here on stage. So stay tuned and zoom in.
Yeah, for Siemens Energy, Formnext is a key fair, and it's really a melting pot for all additive manufacturing technologies. And we are meeting vendors, we meet suppliers, and we meet also our customers where we deliver parts to.
So Formnext is very interesting for us because we use a lot of 3D printing in-house and also for our production parts. We use it in-house for product development and concept verification, also for testing. We use it, like I said, for our production parts as well. So it's good to see all the different capabilities of the printers here and the different materials, as well as like the 3D scanning aspects as well.
So we are focused mostly on the maritime sector, also motion tooling, research centers, universities, and on the additive construction side.
We want to see the newer materials that are released, also the new machineries. We are based with mostly polymer systems, but we are also looking very much now into metal powders and metal AM, which is very interesting for us.
I come to Formnext because I'm studying mechanical engineer, and it's very interesting to see everything about 3D printing.
The DAN lab is located in Portugal, north of Portugal, in Guimarães. We are located in the campus of the University of Minho, and we are a laboratory of additive manufacturing, but we have other technologies like subtractive manufacturing or forming manufacturing, and all the products that you can see in our booth is made by us. Design, all the product is made by our technologies that are located in our laboratory. So you are invited to see what we have made here for the Formnext. Our mission, our vision is in fact to help the small and medium companies, in particular in Portugal, but we want also to grow up and to have collaborations with other companies in Europe and to make networking. I'm very proud of my team and the products that we develop with the collaboration with different kinds of industry, from different sectors, from automotive sectors, health, aerospace, tooling industry, and shop floor in different kinds of industry. So don't forget and visit us in booth F59 in Hall 11.
celebrating 10 years of Formnext this year. The 11th has obviously already started. Make it safe, make it AM. Bye. Formnext 2025, day 3. And although Summit celebration is already over, there's still loads going on. Come check it out. Formnext is all about scanning, prototyping, casting, powdering, processing, and we've seen the entire process chain. But where can you actually have fun here? We'll find out. Wow, this is a big guy. I wonder where he was printed. Remove the structures with a chisel.
Hello, ladies and gentlemen, and welcome back here at the industry stage at Formnext 2025. And I don't know how you feel, but on the last day, I always get a little bit sad because it's over already. But the good thing is that sometimes you have some specific program points where I'm so glad that you can moderate them. And this is one of them, because I welcome you to the panel with a title, Rethinking Supply Chain with Additive Manufacturing. And in my opinion, considering the content we had here over the week, this is a perfect wrap up. It rounds it all off what we discussed over the last few days. And yeah, let me give you the introduction. So for years, many of us imagined the same vision, and I did very heavily, I must admit, yeah. A world where a critical spare part no longer takes 6 months to arrive, but can be produced locally within days. Today, this vision is becoming reality, at least some of them say. So additive manufacturing has matured, and across industries, from rail to mining, pharma and defense, we now see real use cases of on-demand production, digital inventories, and decentralized manufacturing. So in this session, what we want to do is we will explore how far we have come, where still there are some obstacles, and what will it take to establish AM as a reliable, scalable supply chain technology. And you can't do such a panel just with me, because you need proven experts, and this is what we have here today. So let me introduce our guests to you. To my left, Espen Sivertsen, CEO of the Ivaldi Group. We will later talk a little bit what you're doing exactly, Espen. Great to have you here. Thank you. Then we have Nicholas Tarantino, Project Lead, Sustainable Steel Region of Sweden. Nicholas, good to have you. Thank you.
Thank you.
Then we have Piotr Mutika. I hope I put the last name correctly.
Perfect.
Perfect. Thank you. You are head of 3D Printing Center of Excellence at Roche.
Big fan.
Great to have you. And last but not least, Martin Huber, Project Officer, Additive Manufacturing Logistics at the European Defense Agency. Martin, good to have you. So let's kick off, Espen, with you. So remember when we had our briefing call, you mentioned that the real bottleneck is not the printer, printer that we have on site, but let's say the system or the ecosystem around it. Yeah? So you work mainly mining, maritime and heavy industry, because this is what you're focusing at. Yeah, where do we see already digital networks on site already? And yeah, what still has to be done to get it really qualified at a local manufacturing standard from your point of view?
Yeah, I mean, I think it's worth acknowledging that actually it's already happening.
Yeah.
You know, the future is unevenly distributed right now. But there are companies like Equinor and others that are actually actively now building digitized libraries, producing things on demand. And if you look at more traditional supply chain, it's already happening there as well, or has been happening from an on-demand perspective. There's always someone, you know, locally that can do things for you. The challenge there is it's not digital, and so it's much harder for procurement to integrate. So one of the big challenges we're working with right now is how do you make it easy for owner-operators to be able to order things on demand without necessarily having to go through a 6-month qualification and certification process.
Okay, thank you so much. Nicholas, I mean, you are responsible for Sweden, yeah? And the thing is, you mentioned something. I was quite, at the very first thing, I was quite irritated because, but you were totally true. So supply chains are often good enough. Let's call it good enough, yeah? Creating low urgency. So this is probably one of the reasons why we're not speeding up in establishing AM as an additional supply source. So if you look at your national project, what finally convinces then traditional industry using AM seriously?
Okay, yes. Actually, I can, under normal conditions, I would say that the supply chain is good enough. It's a good distribution system. They have the spare parts in stock, and we have good suppliers that do everything to deliver spare parts, even if you have to fly them in. So that's. But now with all this, what's happened in the world with the geopolitics and trade barriers, we have to think differently, and also this company sees this now. It's happened.
Yeah.
So I think we have to go for more additive manufacturing to meet this trouble.
Yeah.
Yeah.
Very good. Yeah, Piotr, what is great about having you here on stage is because you already established it, kind of, right? I mean, there is an insecure supply chain, or with not enough supply, let's call it that way. So, so how does Roche use internal supply chain with additive manufacturing right now?
Not yet very mature way, I would say. So I'll start with a little critique. It's been probably between 10 and 20 years additive manufacturing is present in our business, but still rather locally, rather on problem-solving level than reaching any strategic area or core business areas. That's what we're trying to change. And we try to push 3D printing everywhere we can in the company, hoping that some of those experiments will bring us those more serious strategic areas. And we try to do it also very informally, so probably a bit unusual approach. That's the plan.
Yeah, so you let everybody test it and then see how it works for them, and yeah, okay,
Exactly.
We'll talk about that later.
Yeah, we'll
So Martin, nowadays getting to any fair, believe me, any fair, and saying you're from defense results in the highest interest. So that's great to have you, basically. So if we talk about defense logistics, if we talk about reliability, I mean, there's no way around, let's put it that way. Where do you already see in your field AM already contributing to the supply chain and defense logistics?
Actually, what we want to get the maximum out of this technology, and we are not an OEM or a prime. We have the user's perspective, and how we approach additive manufacturing are related to the use cases. It's not only a logistics supply chain, but defense is also interested in repairs. You can imagine that not everything you can exchange in a battle or a conflict scenario, so you have to repair. And there's some promising technologies already that can contribute to our repairs activities. Let me say terminology used for that, it's typical battle damage repair, how we call it, air battle damage repair, expedient repairs. This is how we approach it. So because of an obstacle why we cannot get fully use of AM by now. The logistic supply chain, let me say, is protected by the intellectual property rights.
Okay.
And we are not there. We are on a long way to get there, to get in contact with the OEMs, with the primes, and to convince them that to get full use of additive manufacturing technology, because let me say the characteristics of AM, they're very sexy and promising for armed forces, to reduce, and this is also a main terminology, reduce the logistic footprint of armed forces, and this is where we want to get to. So we are in an exchange and an approach to the OEMs to convince them that it's worth and valuable to invest in additive manufacturing technology, because it starts already with the design phase.
Could I add something that I forgot to say there? To convince the industry, we have to show that the AM system, because we see it as a system, is better than the traditional system. And there's a lot of challenges, but I can see 3 challenges that I will point out. And one, we always talk about the procurement, because if you are in the industry, you always have indicators that you will buy as cheap as possible, but the total cost can be much higher. And it's also about, we have already structural supply chain. So it's about trust. You as a customer have trust with your supplier. You have guarantees. You don't want to disturb this. And the third, I think, which is a big challenge, is the personal responsibility in the industry, because you don't want to take risks.
Yeah.
As a maintenance manager, or if you are in the purchaser, you want to do as you normally do, because if you avoid from that, you got a personal risk.
Yeah, I can imagine, Martin, this is a big issue with yours.
And this is actually one of the obstacles we have. We have to work on our language, the language we are sending to the OEMs, because the calculation is always on the part costs and production. The real costs, they appear afterwards when the logistic supply chain is coming into effect. So with the shipping of the stuff anywhere in this world, and these are the real costs. And what we are facing now is the situation when we talk to OEMs. I approach many OEMs to try to convince them to invest in additive manufacturing technology. I always get said, hey, sorry, but AM is just interesting to a maximum of 1,000 pieces, and afterwards it's whatever.
Yeah.
And this is a language we have to change. We have to overcome that, and we have to look at the real costs, because the benefit is also at the end user and on customer side. This needs to be done to increase the implementation and acceptance of AM.
But you're up against some very established and powerful forces of inertia when trying to do that. And having spent 8 years talking to OEMs in the industry and trying to make them change, my conclusion is they are not going to change by themselves. They have to have financial incentive to do so. If you are approaching them with an existing service contract, there is no reason why they would give you any kind of digital files or adapt any kind of system. If you approach them, however, at the point of renegotiation, or when you are creating a new purchase and you make it part of the condition that there should be a digital supply network, then they are willing.
This is very interesting, if I may add something, because it is about procurement, specifically for the public services. And the public services are not ready for additive manufacturing. We have processes, procedures in place. They're 20, 30, 40 years old, and they're used to it, and they don't see the necessity to change it. So this is also, we need to convince, to advertise, we have to overcome this to make use of additive manufacturing.
And there's really 2 elements to that, because it's the same in private industry. It's not just public services, but any procurement infrastructure right now, if you talk to the people doing the actual procurement, their key performance indicators are around savings, and you get savings through bulk discounts. And so, there's no incentive to switch to a one-off on-demand model.
Or reduce process costs.
It's just more work for you. And the second part of that is they don't have the tooling, even if they wanted to switch, to say, okay, well, you have to put it into a digital library. What are the standards? How do you create a digital library? What are the standards for the files going in there in terms of manufacturing? They exist, but procurement doesn't know. Yeah. And so there's a huge gap in adoption missing right now in terms of workflow integration policy. If you work in government or defense or even private industry, if you're buying assets today and not asking for digital stuff, and those assets are supposed to last 20 years, you're doing yourself a disfavor. But we're not making those steps just yet because supply chain works, particularly if you like long lead times and disappointment. But that's the way we're doing it right now. Yeah. So that we need to make it easy to change, and it's not easy to change right now. And as an industry, additive manufacturing is fooling itself if it's thinking, oh, it's the technology problem. It's not the technology problem anymore.
Not at all, I think. Yeah.
I come from a region. There's a lot of heavy industries, and it's kind of anorectic organizations. But you're so slimmed, so you're afraid to step away from doing what you're doing today. So I think also the OEM have to prepare so you can get parts by your local manufacturer. So I think it has to be a value chain which starts from the OEM, and they prepare everything because the customer, the end customer, they can't put up this together.
I think what I hear from all of you, it's like, where does the demand comes from, okay? And if I think, for example, if we talk about tank maintenance, for example, and it could be in a battle repair situation or even regular one where you need it at a certain, let's say, location. And the OEM that you address, what is his interest? Or that's something we have to think in an economic scale. It's much better in an economic perspective, deliver a spare part, even if it has a long lead time, you earn much more money instead of deliver a digital spare part, where some risk are added to it, especially if it comes to IP, etc. So it's much easier, it's well known, and you earn more money, right? Yes. So Piotr, if I remember what you told me about Roche, I mean, there was a lack of supply in a certain field, right? And you solved it by using additive, but you did it internally, right?
Yeah, so we're actually trying to scale it up, and then we're definitely more open to external factors here. But exactly as you described, some, or maybe as we spoke here, we still need to convince different stakeholders and prove the value. So procurement actually should not be an opponent here, should be the partner. And we should not speak through a single position anymore. It should be cross-functional on the country or European Union level, as well as inside a private company. Yeah. Otherwise, it's going to be pushed back due to all those myths today, probably not the reality factors. In our case, it's also a highly regulated market, probably not only one, but this is another obstacle. Although the technology is there, it's not so easy to convince. So the economical factor, the cost reductions are actually the easiest one to pull out when we need to convince someone.
But Martin, I mean, I remember we're talking about standards and regulation. It's also a big thing in your case. So is it really, I mean, something, I think always, if you really want it, and it's technology-wise, it's totally possible. I think you agree, yeah? So is it really so hard to overcome the standard and regulation thing, or is it rather like a put in front obstacle in order to prevent going into that direction? What's your opinion?
Yes, and let me say the biggest obstacles, because you need to understand from an armed forces perspective, about 70% of the assets we are operating, they are older than 18, 20 years. That means they have been developed in times nobody was aware of the potential of AM technology. So they have been designed, developed, produced in the old classic way with old materials. Yeah. And the limitation at this time, So, and of course, the parts that were getting qualified, certified in the classic way, so that with reliability in the background, or liability law in the background, and this is the business model which has been established now. Why is it for us so important now? Because for these assets, we want to keep on operating. We would like to have this digital footprint. Digital libraries. We don't want to have these warehouses anymore, and we don't want to have these supply chains anymore. This is the logistic footprint I was talking about previously. So, and to overcome this, and I think this is also, we have to put hands on the business model, that the OEM is no longer afraid to lose a business model. So the certification and the qualification of parts should be with a digital approach. Also to make AM more attractive should not be the obstacle anymore.
Yeah.
It should ease the qualification, the certification process, because actually all the parameters are available. And I think the standardization organizations, they have to focus on that, to make it more reliable, more attractive, also for the OEM to create their business models. Because we are in synergy. The armed forces, we need the OEMs. Specifically in Europe, it's a synthesis, it's a synergy between the European defense.
Here in Germany, we're talking about offshore wind systems, and we're talking exactly about that, about the supply chain. What he mentioned is that they want to do it, and there's a business case behind it, super easy to calculate, but there's so many insurance risk, and there's always a discussion, are we going to do it with the supplier, in this case, so the OEM, the producer, or are we doing it internally? And everybody pulls up his hands as a red mark in terms of insurance risk and who is supplying the part. How do you see that, especially in the energy?
I mean, yeah, no one wants to make a courageous decision, right?
Yeah.
And the challenge, I think, for anyone working in heavy industry is that change is dangerous. Your job is uptime.
Yeah.
So anything that goes against that, so like if you're on an offshore platform or supplying an offshore platform, the cost of downtime is so high that they literally have $1 billion in storage onshore, one or more of everything, just in case. And 85% of that never gets used, right?
Okay.
So the challenge is, how do you then get the ball rolling in an industry that fundamentally doesn't want anything new because that carries risk? You have to make it safe. Everyone wants to be the second. No one wants to be the first. But there are companies that are taking those first steps now. And there are multiple ways to solve it. You can do it through the OEM channel. You can, as an owner-operator, you already have reverse engineering teams. They already do this for CNC. But they are not digitized at the level where you really could be getting the full benefit. And I will say that even though the per case value may be easy to calculate, what we're seeing is that when you're operating an oil and gas platform or a mining site, or you're doing defense logistics, you're not really looking on a per part basis.
Yeah.
You're looking at the system level. And the CapEx and the OpEx linked to a system level doesn't really, it's so big that okay, we saved a little bit of money on this one spare part, but it's not showing up there. So the decision makers, they're at the level that's too high, and the people on the operational side are at the level that's too low in order to be able to make the change decisions that are necessary.
Yeah.
So I think part of the challenge for the industry is to be able to make it, one, a lot easier on all levels to start adopting, and there are multiple ways to do that. The other one is where we're working very actively to help procurement teams ask for the right things, because it's a lot easier to get an OEM on board when you're having a contract negotiation rather than in the middle of something. And frankly speaking, the OEMs aren't incentivized to shift to a digital distribution model for the vast majority of stuff. 80% of their margins are made in the aftermarket. They don't want you to know how much things cost.
Absolutely, absolutely.
So, there's that element into this as well. And so, the way that I think about this is we really have to make it super easy for both policymakers, for engineering teams, for legal, for OEMs and everyone to get on. And standards play a big role, but actually the financial models play an even larger role.
Yeah.
When you're doing an RFQ and asking for digital files, how do you incentivize the OEMs to share their files? And yes, there's IP, but the music industry solved this a long time ago. This isn't a new problem. It's a new problem in this industry. And maybe not even that, because people have been sending files to contract manufacturers and suppliers for forever. And by the way, they're using email. You know, it's not like we need super secure systems for the vast majority of this as well. So yes, for defense, there are higher requirements. Aerospace has been doing it for forever, though. And so I really believe right now that where we're sort of missing some work is how do you bundle this together so that owner-operators can start taking the lead and asking for the right things? Because that's where the industry is shifting. And, you know, the great news is it is happening. Slower than I would like. I started 8 years ago. It's going to take another 8 years at least to get this in place. But it is happening.
I mean, especially in defense, Martin, don't get me wrong, but everybody, I mean, honestly, I'm a private person, Martin. There's not a day where we don't talk about defense issue right now. So if there's any pressure in terms of a positive, I mean, there's the negative background, but positive in terms of arguments to discuss with OEMs, with stakeholders as well, should be defense right now, isn't it?
Actually, it's about the situation, the general situation we are facing right now.
Yeah.
We know on the east border of Europe there are dark clouds, and these clouds getting darker and darker. And military is made for be prepared for the worst case we can have. So we have now a time, and I'm not sure if this is really the perfect time for the implementation of additive manufacturing in the or to overcome or to replace the old way of working and business models, because it needs time. Okay, but this is exactly that what we do not have, and the perfect lesson learned for it we can see in Ukraine. It's the perfect lesson learned. When you're under pressure, then you can get the fully potential out of it, of AM technology, to keep your assets on running, to keep it operating, and to get out the fully potential. This is the game-changing potential of AM. And honestly, now we have still some time, and it needs an initiative. It needs an understanding, an increase of communication. We have to get in touch with the OEMs. And I would say he was talking about that partially. It happens already, that some are waking up. But this is maybe also we have cultural differences in the different European countries. It's culturally driven. Scandinavia is more open for that than the rest of Europe, to be honest. This is from my perspective.
Yeah, it's crazy, but I mean, Piotr, one thing that is really, I mean, you're a step further, I would say, yeah. One thing that is really crazy for me, you have this possibility, and we talked about it for years, honestly, and there were so many obstacles, and we talked why this is not possible. Now it is possible. I would say it is possible. Piotr, why we're not doing it, and that would be interesting.
That's the topic that is everywhere here, right? Why not bigger? I think it's here, maybe also on paper. Technology is ready, no doubt. Even for advanced pharma needs, majority of our needs could be fulfilled. It still requires certain effort. So certification is the easy part. But what I think I miss is the easiness of reaching for it, especially from the large corporate perspective. Today, even innovation is defined differently. We, of course, innovate internally, but then buying innovation is quite standard on pharmaceutical market. We cannot say the same about additive manufacturing market yet. Majority of companies would sell technology itself. So the service provider, the products and services is the part that should develop the quickest, that substitute of.
But I mean, I just want to sort of like drive this home, right? I've been walking around the conference, everyone has. Show me one booth that has a part with pricing and like the full business case.
I thought about it too.
Show me one booth here in the conference.
What we can take home immediately to deploy.
And we're talking about dealing with supply chain, right? Like this is insane, team. You know, like I'm on the AM team. I've spent my entire career trying to get this to work. But we as an industry are not making it easy for supply chain.
Yeah.
We are making it so hard.
Yeah, but the thing is there that then, I mean, let's get back to the point. The technology is there, and I understand fully. I'm a true believer in thinking in verticals and delivering solutions, not discussions or exploration. I think this level is over in order to get profitable. Yeah, but on the other side, talking about defense, pharma, energy sector, why isn't it easier to start with best practices or use cases in terms of, because what I hear a little bit sometimes is that we always think in the final solution. That's sometimes hindering us of really getting on the road. So especially, let's say energy, and you have like mining in any African country. Of course, you can solve the biggest problem, the highest cost part that you can deliver there on locally, but why not start with little parts that you usually can deliver the usual way, but get into the experience in order to convince people. And once this is established, then, I mean, you see how it works, then it should be easier to convince, right?
Yeah, but I can tell about our project in Sweden. We are driving a mission in Sweden, On Demand 2033. And this is exactly what we want to do, is to get people closer to the additive manufacturing, to the on-demand manufacturing, to show them what's the benefits. And even if you have a workshop with cutting and traditional manufacturing, you have to feel it on the parts that have been printed. So we want to get the technology closer to the people out there in the industry. And we are focusing on, we have a 10-year mission. And we are focusing on 5 dimensions. It's about the business models. It's about the technology. It's about the infrastructure. It's about policy. But it's also about culture and the competence. Because at least in our region, the competence is really low in this. And it's both from the designing of products to manufacturing. And the customer, the end customer. So all these chains have to get closer to the additive manufacturing. And if you are a part in this traditional chain, it's also, there's a lot of conflicts. Because I might solve this production line for a low cost, just to have could sell spare parts.
Yeah.
So you have traditional business models that
you break with old models, for sure.
So that's the reason why we're doing this.
But just to piggyback, because we're part of this project, and the thing that we're quite excited about is that, to my knowledge, this is the first time a region in the world is saying, okay, we're going to look across different industries at the total volume of parts that could be additively manufactured or produced on demand. And we're going to create infrastructure that supports that. And that makes a lot more sense when you think about it from a total cost perspective. Because the same equipment could be used for a wide variety of industries, and in fact is today, but it's not being coordinated in any way, shape, or form. And what Niklas and the team has really been pushing for is like, how do we get there? And I think that's going to hopefully lead to other areas of the world being able to do similar.
But what I would be expecting, as I mean, Piotr, you explained it perfectly, in my opinion, is of course the people need to understand how AM works and what could be the benefit, but we are missing kind of vertical solutions right out of. Well, I take it and there is it. Isn't it then the right way? Because this is what I feel we're doing for 10 years now, talking, explaining AM. Is it really the way to explain AM, Martin, or not saying, hey, this is the problem we have, let's say a conflict, worst case scenario, this is what we need, and you show the whole chain, how it would work, and then create a use case?
I would say, if I may say this, from a European perspective, when I look at other continents, they have an AM strategy, and Europe hasn't.
Yeah.
It would be very, very helpful if the European Union would have an additive manufacturing strategy, a common approach, how to support this technology, how to promote it, and how to implement it. From a European perspective, and if I may say this, additive manufacturing is pretty too much still in the innovation corner. We have to overcome this. Additive manufacturing is no more longer just an EDT, okay? It is a serious manufacturing method, a capability. So a focus more on implementation would be very helpful into capabilities. For militaries, it's very interesting, and this is also responsibility of the armament industry. It's not always about, I cannot always ask for fundings and support from the European Union. This is their own responsibility in Europe as well. because we protect their business model. We protect their plans, their sites. They are produced in Europe. So armed forces are there to defend our values. So, and I think they should also have an interest on their own to invest in the future, if I may say this here. It's not a critics, it's just an encouragement.
No, absolutely. I totally agree. So we had exactly the discussion yesterday in the morning talk with AM Europe. There were what we were discussing, so that they try to work on a strategy together with politics. But if we look at China especially, I mean, this is established for, I don't know, 15 years already, that they consider AM in their strategy, and US does the same. So I totally agree, Martin.
We need different arguments and different tools for different decision levels. Democratizing was a great idea in our case to build a portfolio. Now we just pick which area of company we want to explore and then what can be done there, look for the benefits. But I miss the top decision level arguments. This needs to come from the industry or maybe from country levels. This is really impressive, Sven, here.
But talking about democratizing, Martin, so is it like, I mean, I know several projects from the Bundeswehr at least, so I'm not so familiar with the European activities, but either is it a maritime project, or I heard a lot about drone development, for example, together with AM. So how is that working on your level? Are you like establishing joint forces there and letting everybody do and then collect what is already happening, or how's that working in your work?
So actually how we do that, or how we facilitate, we are facilitators, European Defence Agency. We work with the member states together, willing to invest in additive manufacturing technology to get use of it. We do that in a project framework. We call it mutual logistics support. And for mutual logistics support, you need a basis for that. And the basis are the common standards. And this is what where we put hands on at the moment, developing for 8 different areas: processes, technology, quality management, training, education, train as you fight, a very important aspect, also for the implementation, acceptance of additive manufacturing in the civil market, not only for militaries. And this here we have a big issue, a big gap. We have to put hands on it, strategic-wise. And so with these standards, we enable our member states to support each other. We have also in mind, this is the strategy, to create a European-wide network with additive manufacturing capabilities, industrial and military capabilities. It's a digital approach that, in the case of the cases, that we are able to get full use of AM potential and to support each other.
Very good.
This is the way how we approach this topic.
One thing that I really do not understand, and as I'm external, I can ask this question, is we see a lot of fragmentation in the industry. That means that's what you mentioned. So we have the ones that are focusing on post-processing, we're focusing on the machines, the materials, etc. But basically, if we want to come to vertical solution, or let's say single use case solution, let's say only one part, we need the whole chain to do so. But I know from various exhibitors here, they are trying to focus on different, let's say, industries. But why is that not happening, that everybody thinks in the whole chain, Espen? I mean, this would be the solution, isn't it?
Yes, no, because I think it's worth differentiating between vertically integrated solutions around a single part or component, which to some extent I think is starting to happen. Like if you walk around, you can see collaborations. There's also collaborations happening on integrated like supply chain level solutions. I think where it sort of stops a little bit is we're not really thinking carefully through the customer, like the end use needs. So when you're like, just to use mining as an example, when you have, the decision makers high up in the mining system, they're not really thinking specific technologies necessarily. They're looking at uptime. They're looking at, throughput. They're looking at statistics that aren't directly connected to spare parts at all. Spare parts is a very small part of a very large landscape. So really what you want to be talking to them about is the promise of new supply chain methodologies. And it's a very, very simple proposition. You have spare parts that today are being shipped all around the world, and you could be shipping them digitally. And one of those solutions has a lot of risk and carries a lot of fuel costs, and the other one doesn't. Plus, by the way, you could be creating local jobs. It's a no-brainer. However, how do you get there? And no one wants to make career courageous decisions. So there needs to be a very clear-cut business case. You need to be able to tie downtime and these like top-level items down into like, this is impellers. You're spending $7 million on impellers every year. How could you be spending that money more locally in South Africa or wherever it is that you are? And what does that ecosystem look like? And that's the dialogue that's not really truly happening right now. Vivaldi is trying to lead the charge across our customer base. But in order to get that $7 million of impellers into on-demand local manufacturing, now you need to work with procurement to convert all of those contracts as they come up for renegotiation. You need to work with local supply chain to actually get the qualified systems in place. It takes time. And so, you know, I think if I was to answer your question from an industrial point of view, like why aren't we seeing those holistical solutions? It's because everyone is such a small piece of a larger puzzle, and the missing connectivity is on the business case side. Once money flows, everything else happens. But the money isn't flowing yet. And so it's hard for anyone to take kind of like a leap of faith and be like, oh yeah, we're going to be an OEM that just produces this without any business lined up already.
Yeah,
right?
absolutely.
So it's this chicken and egg problem. And there are a lot of chickens and a lot of eggs, but they're not working together.
It feels a little bit sad what you're saying, but it's okay. Nicholas.
And I think also it's a matter of competence. Because you have the experts in additive manufacturing and you have the experts in traditional CNC cutting. And if we have a traditional company, you don't have the competence. You have to reach out for competence, you have to invest, it's a lot of things to do, and you don't have the customer, as you said. So that's a tricky part. But what we see now in our region is that companies trying to reach this, they hire people that have the competence in additive manufacturing, or if you are the expert in additive manufacturing, you hire or invest in post-processing. So, but it's a slow process.
But I think just to talk up the On-Demand 2033 project a little bit, one of the things that I think is being successfully done in Sweden that others should take inspiration from is it's not one technology. First off, it's on demand, right? That's the value proposition. And then to reach on demand, there's multiple things that need to happen. And if it was easy, we'd be doing it already, right? Supply chain is complex, it takes time. But you know, the reverse engineering and the rapid response component, it goes beyond a single material or single technology. It's about having a system so that procurement in the pinch, and by the way, speaking of career courageous decisions, no one wants to explain to their boss why a $2 bracket has stopped a $2 billion production system, right? So the incentive structure is there, but they just don't have the tools. And if you can create those tools on a regional basis, now you're talking.
They would need to have a system where they can take the decision whether this way or this way. Technology open, it doesn't matter which technology.
And it has to be in the dashboard that they're using on a daily basis already.
And we don't have that competence to really say that we should use them or we should use some other technology.
Yeah, but in this case, I probably disagree, as I may say as a moderator. I disagree in this. We're always talking about knowledge and understanding, but let's say I'm a procurement guy. What I need to understand, so first of all, as you said in the very beginning, it should shift from cost per single part to cost per whole process or benefits of whole process. This should be the incentive of a procurement guy, first step. And then, in my opinion, it's no longer so important whether this guy decides in the direction of AM or traditional methods. It's rather, he looks what solution is on a holistic approach better for the company. That should be the approach, first thing. But Piotr, what I really like, in order to tackle a little bit thing of qualification, as far as I remember, you said, let's do free flow. Don't get me wrong, which sounds really crazy as a company at Roche, to be honest.
I won't say it officially.
Yeah, no, but I will say officially. So you let the people do, and like in terms of, please refer quickly to the thing of the tissues, where you needed the tissues, in order to see how solutions sometimes work.
So first, addressing your first question, just the technology being there, it's not enough. First, we need 27 different ones, so some form of integration support on a more holistic level if needed. But our idea to grow this was to, again, democratize, a catchy word. So we enabled 3D printing everywhere we could, including laboratories, production areas, and even low strategic ones, like some plastic elements used everywhere around. And it starts to pay off. So it is one of the ways to build this conscious to the level. It will reach the decision-making level finally, hopefully. Still, we need a solid partner on the side, because if the decision is there, we need to scale up immediately. Otherwise, the costs of change may be not accepted.
Very good. So we have 5 minutes left, and what we need to do, guys, sorry for that, we need to get a positive outcome of the discussion. And I heard too many obstacles. So Martin, I start with you because, as I said, I don't want to use the word pressure again, but Martin, I'm so sorry, that's what we're experiencing right now, isn't it?
I'm used to handle this.
Yeah, okay, go for it. No, Martin, I mean, we were talking about the worst case. Let's hope that the worst case never happened. But anyway, we are in a time where everybody expecting you, as you are sometimes the facilitator, to push now as much as you can in order to speed up. So you mentioned regulation, etc., pp. But the worst case might happen in 4 years, and I know how slow the processes are if we talk about military and defense and regulation and state strategies. Do we have the time to wait for a common strategy? Do we have the time to wait for regulation? And what do you do to speed up, and where's your hope?
This is a difficult question.
There were more questions at once.
Specifically on the time, because we do not know when these case of the cases happen. In this regard, I would say we might be a little bit too late already.
Yeah.
But there's always hope for everything. And let me say, for me, it is very important that the different stakeholders, that they talk to each other. It needs also to lead to some different initiatives. And this is also my plea to AM industry, to be honest, to the manufacturer, to the material industry, and so on and so on. Do not give up. There is still a way to go. And don't wait that the people come to you. You have to go to your customers. And you have to communicate. You have to convince. You are actually the ambassadors, ambassadors for additive manufacturing. Most likely, after the invention of a wheel, the second game changer in human beings, to be honest. This is my humble opinion on that. That's the reason, of course, there's hope, but there's also a long way to go.
Okay. Espen, you get a more concrete question, because I just get on my ear. I shouldn't take the question longer than the answer, so I try my very best. When can I see an oil platform where they don't have 7 billion in stock as spare parts, but they're printing their spare parts on site?
That's a great question. I can tell you that most likely the next oil platform being built will have digital inventory.
Awesome.
Yeah. So depending on the operator.
Yeah.
But they are aware, they are looking, and they are building systems like crazy. And energy will be one of the first non-aerospace or medical industries that have figured this out.
Very good.
Can I lift one positive thing?
Yeah, please.
Because when the new generation, if you come here to this exhibition and you go to 12 upstairs, you see a new generation they have this like as an interest. Get them out in the industry to make change, but because there's a lot of old men out there.
You speak for yourself, Niklas.
But me and some others, not you. So we need their help, and they are so interested to make this happen.
Yeah. Piotr, when can we, I mean, you solved already so many problems. When you get rid of your tissue supplier?
Hopefully soon. So the maturity is different, but I liked what we heard here. Do not get discouraged, dear industry. We just need a message directed to the decision makers. We are already quite well with the users, with engineers, with product owners. They are with us. We need more executive messages, so more economically driven, strategically driven, etc. Maybe that's the integrator role again, not just a technology provider. And then in our case, the printers should be in hospitals, not only in the labs. So you can actually also produce drugs or some forms of it directly at the place of use. So that's the holy grail. The tissue is a smaller step to get there.
Yeah, no, that was, but this was a perfect example,
so
right?
Tissue, maybe I'll explain. There is a shortage of some parts or articles. In our case, it's a tissue that we need to research. And this market will not grow. So that is probably the only way to make it.
By the way, I didn't ask you, Martin, but I need you to ask you, and we have time for that. Is there already a printer somewhere in the world in place and in charge of doing on-site repairs?
Yes.
But you are not allowed.
Short answer.
Because
we are running out of time.
Yeah, of course. Of course, Martin.
I don't want to mess up your weekend.
No, it's totally okay. So, ladies and gentlemen, I think I think it was super interesting. It was not as promising as I hoped for. No, I'm kidding, but I'm seeing the challenges, and honestly, what I really like is that we probably are reaching the next step of obstacles because we solved the first one. So we solved technology, as you mentioned the dimension. I think technology is solved. It's rather than thinking in systems, being facilitator, bringing the stakeholders together, doing the next step. And you created hope, at least on my side, that I can see and live with the solution then later. And Martin, all the best for you. We all trust in you that you're pushing that forward. Thank you.
Thank you very much for having me.
And thank you, dear audience. You should stay tuned. You will get some Formnext highlights now. And after that, let's say, close a little bit the program, at least at Industry Stage, and you get a global overview of everything we talked about the last couple of days, and this is worth watching it, so stay tuned. See you in a few minutes.
10 years Formnext in Frankfurt. That means 10 years of innovation at Renishaw and 10 years increasing productivity in AM systems. If we have a look at it at the journey, we talk about high efficiency quad laser module, then Tempus technology, Libertas, long life filtration system, just to name some of these milestones which make AM technology today extremely productive. Let's have a closer look to it. Hey Chris, how are you doing?
Rhino, I'm good.
Great first day at the show.
Brilliant show, fantastic. Just what we've been looking forward to.
Excellent. This is here really Renishaw at its best. We have a whole process, additive manufacturing, milling with our partners from the company Chiron, and final inspection with our latest and new Equator X. But what I particularly like is our digital workflow with our partners from Siemens, where we design the part, we design the process, and then we implement it in one go into the factory. That's really fabulous. What about the 500Q Ultra? What's special about it?
So the Renishaw 500Q Ultra system is really highly productive, and there's a number of reasons for that. Number one is that it's got 4 lasers within a very, very small, compact footprint, which is really important for some of our high production users. It also then leverages Tempus technology. Tempus technology is patented process from Renishaw, which means the laser actually operates on 2 different layers simultaneously while the machine is wiping. So effectively, powder is being spread constantly while the lasers are still firing. This is an algorithm we've developed, patented, and is being implemented by many of our largest serial production customers.
Excellent, thank you very much.
Thanks, Rainer.
That was not it yet. We're looking here at our latest milestone in increasing the productivity of our systems. Hi, Luis. What is it about with Libertas?
So the first thing to say about Libertas is that it is a software product. So for our existing RenAM 500 customers, there's no additional hardware required. And as the name suggests, Libertas gives those customers the freedom to dynamically optimize their laser parameters across all regions of a geometry. And this is maximizing the quality that our customers have come to expect from Renishaw.
So on these parts we're seeing here, what kind of reduction of supports we're looking at?
Yes, so what this freedom means is that users and customers can basically now print with vastly reduced supports. So all of this fewer supports means that we are saving on material, but we're also improving the surface finish of the parts. And the reduction in supports also is a benefit for post-processing.
Yeah.
So we're saving time taking those parts off, which is having a positive impact on productivity and the environment. So these are a range of parts from different industries. We've got some dental, medical, aerospace, consumer electronics. And what we've got is a range of savings from Libertas. So from 60%, 80, 96, and this part has got a 97% reduction in support material.
And there are also builds now. We can build with Libertas. We couldn't even build without Libertas.
Absolutely. So on this particular one, where we've got one row of parts, that's because it wasn't possible to build it in a stack with the supports. Impossible to get the heat out. Once we apply Libertas, then we can build a whole stack. So this technology really opens up the applications for our customers to print parts that maybe weren't possible to print before.
So I think it's fair to say we maintain the market leader in ratio productivity to footprint of our systems even more with Libertas.
Absolutely. It's an addition to the Tempest technology that we introduced a couple of years ago. Now we've got Libertas, all aimed at productivity.
Excellent. Thank you very much.
No problem.
Pleasure,
Thanks,
as
Reinhard.
always. We had a fabulous first day at Formnext 2025, and we truly enjoy our journey through innovation. Thank you very much.
Hello and welcome back, ladies and gentlemen, here at the industry stage at Formnext 2025. I tell you what, the whole week I'm looking forward to the following keynote, although, and that's a sad part, it means it's the official closing of our content program here on this stage. Our world has become more complex, and I think everybody can agree, from rising tariffs, that was a topic that was dominating the last few months, to fragile supply chains, and what we just discussed in our panel. And in this environment, companies are searching for smarter, more resilient ways to produce. And additive manufacturing in this regard is no longer just about innovation, it's becoming a strategic response to global uncertainty. To explore how AM can unlock real business value in volatile times, please welcome the person who has been shaping this discussion on the global stage, and I'm so happy to welcome him here on stage again. Please welcome Dr. Wilderich Heising, Director at Boston Consulting Group. Wilderich, stage is yours.
Thank you very much. Good afternoon. It's so great to be back at Formnext, and actually a couple of very inspiring days are behind us. And I have to say, when I look around and when I walk through the halls of Formnext, I always feel so inspired because there's so much innovation going on. And we see so many things that are happening and that bring the industry forward. And so my personal outlook is actually positive with and inspired and engaged with all these new things that I've seen. And today I would like to talk about how we can actually make additive manufacturing as a strategic response to really unlock also business value and to take the power of innovation that we see here to the next level and turn it into value for the user of the technology. My name is Wilderich Heising. I'm a partner and director at the Boston Consulting Group. I joined roughly 20 years ago. I'm fully focused on operations topics, especially manufacturing and supply chain, and I have the honor to lead our additive manufacturing topic globally for BCG. As such, I had the opportunity to do multiple projects along the entire ecosystem in additive manufacturing, spanning really all the way from material players to service providers, equipment providers in the middle, and the end user of the technology. And that has helped me to form a perspective on the market that I would like to share with you today. So today's agenda is basically focused on two elements. First is I would like to look into the additive manufacturing industry as it stands today, and I would like to look into the growth potential that we see, and also, of course, the headwinds that the industry is facing. And then I would like to look forward to think about how we can actually leverage key trends that we see in additive manufacturing to really unlock business value at the end of the day. With that, let's dive right into the first topic. So, the additive manufacturing industry is undergoing a new phase of consolidation. And that is actually something that is rather normal for industries that grow up, that become mature. So when we think about Formnext a couple of years back, we saw the startup scene growing and growing and growing every year. Multiple different players out there that are all bringing their offering basically to the market. And now we are facing a consolidation wave that's happening. It's consolidated around a few equipment players. And I think this is something, when we look into other industries, that is a very natural step that happens. It also tells us that that industry is now maturing. And what we'll have is then eventually a couple of larger players that actually have the funds and the power to drive the innovation that we see here, to drive that forward and to make sure that it's sustainable and stays. So what makes me positive or think positive around things is that when we look around at Formnext, we see a lot of use cases that actually leave the status of toys and go into real applications, into the real stuff for industrial applications. So there's an increasing trend towards manufacturing use cases. And these manufacturing use cases will be decisive in order to grow additive manufacturing at large. And additive can capitalize on a couple of ongoing trends like mass customization, decentralized production. We heard in the panel before the issues around supply chain. I will also cover that a bit today. And rising product complexity. With additive manufacturing, we actually have an answer to those things. With that, we are also looking at growth rates in additive manufacturing, and we see slower growth than it was anticipated in the past. But actually what we are seeing is we see a beyond the hype growth rate now. Yeah? We are seeing additive manufacturing world that has become real, that has grown up. We see parts that are really there and that are basically giving us the proper quality that we need for industrial applications. So we don't need to dress up additive manufacturing anymore. We don't need to make it look shiny and sexy. It's a technology that's here to stay. We find the use cases and we see use cases where additive is really the differentiator. And that makes me very, positive thinking about the future of additive manufacturing. A couple of things to think about who will actually survive in the additive manufacturing industry. Because I mentioned the headwinds, and so surviving sounds maybe a bit drastic, but the industry is driven by major players focusing on integrated solutions. And I think this is something where we really need to think that forward. So it's encompassing technology, material, and services, bringing these things together, making sure that we partner up or have that all in the offering for the users to make it easy to navigate the maze of additive manufacturing. The winners are those that will be able to tailor their offerings to meet differentiated market situations in Europe, in North America, and Asia. Innovation leadership is a must-have to provide value. So we really need to think through how we can innovate. And when we look around at Formnext, I think there's a lot of innovation happening. Then smaller players really must find their niche in the market. So they must be highly specialized, have a unique value proposition to make sure that they have a meaningful position in the value chain. And also larger players need to think through how they drive the technological innovation forward, and also must assess, economic moves like M&A activities and so on to gain critical mass. With that, let's go into the trends that we see at the Formnext and that I also see in the larger market when I look back the last year and when I look ahead for the year to come. So there are 4 key trends that currently dominate in additive manufacturing. One is manufacturing readiness. So it's about scaling additive manufacturing for complex but also tailored solutions. Second thing is supply chain resilience. So let's build this resilient and adaptive value chain in additive manufacturing. The third key trend is digital and AI. So it's really boosting additive manufacturing with AI solutions and with end-to-end software solutions. And the last thing, but also not the least thing, is material and tech innovation. So there's a lot of new materials that we see here for higher performance, for scalability, and also for sustainability eventually. So let's now dive into each of these four trends for a bit. First one, manufacturing readiness. So 3D printing is really shifting from prototyping towards scale manufacturing. On the one hand side, of course, it's our prime technology when it comes to rapid prototyping, and it will also remain that dominant technology for prototyping because there are a lot of things that additive brings to the table. I don't need to talk about that, I think. But the key thing for us, in order to make sure that additive manufacturing also has a strong market in the future, will be the step towards manufacturing applications. And when I speak about manufacturing application, there are basically two types of applications. One is the tooling components, so making sure that we have manufacturing toolings in place, tools, jigs, fixtures, molds, whatever, what we need in order to run a smooth production process and also an efficient production process. And the other component of that manufacturing element is really having production parts at the end of the day, end-use parts that we can bring into aircrafts that fly, that we can bring into cars, that we can bring into medical devices, and so on and so forth. And in order to establish that manufacturing ecosystem and that manufacturing use cases, we really need to think about the value that it can unlock. So typically when we think about value, we directly jump to direct part comparison, where we compare an additively manufactured part with a traditionally manufactured part, and then we do the math and say, well, if the additively manufactured part is more expensive, then let's scrap it. It doesn't make sense because it's more expensive than traditional manufacturing. But this falls very short when it comes to manufacturing context. Because in the manufacturing context, we really need to think about the total cost of ownership concept. So there are many more value drivers that are relevant, that are decisive when making a decision towards a certain technology for production processes as a manufacturer of parts. So of course, direct savings is the first one. People will always look at the direct savings, but then there are other things like capacity increase. So if you're able to take low runner volumes down from your traditional manufacturing lines, move them to additive, and then focus your traditional manufacturing lines on your high runner products, then you can really unlock margin and productivity of your high runner products on those traditional manufacturing lines. And then at the end of the day, it doesn't really matter whether a part on the low runner part is a bit more expensive than on a traditionally manufactured part, because you can unlock much more value in the broader sense. Same thing, supply chain resilience. So we've heard about supply chain and challenges in supply chain. When we look around ourselves today, tariffs is also a word that we've heard already. So there's a lot of disruption going on out there. So with additive manufacturing, we can help to overcome these challenges in supply chains. We can reduce inventory significantly by basically having on-demand spare parts without the need to store a lot of things. And then, of course, improved lead times, logistics savings, AM-enabled design changes, and further ESG benefits. These are the secondary value drivers that are also very important for manufacturers at the end of the day. So my message with that is we really need to think through how we can unlock value in a total cost of ownership sense, and not just, look at the direct part comparison. Double-clicking into that a little bit, direct part comparison and direct savings. When we look at basically the projections and how additive manufacturing will evolve, then we see also, of course, with all the innovation that's happening, we'll also have a significant price drop for the user of the technology, both basically in the material consumption and in the material prices, in the machine prices, and so on and so forth, but also in the labor price and the labor cost rate, because more and more automation will be part of an additive manufacturing ecosystem. So there's basically a future where the prices will come down significantly. But the second point that I mentioned is this capacity unlock. And this is an example of a project that I did 1 or 2 years ago. Basically, on the left-hand side, we basically see the low volume series that were all also produced on the traditional manufacturing. And with all the changeovers that you need when you have a batch size or a production run of, just 50 parts compared to typically 1,000 or 2,000 or 5,000 parts, you have a lot of changeover processes. And when you have a changeover on a production line, the line is stopping. You don't produce any parts. And in this specific situation, we basically had 75% of the time was setup time and only 25% was productive time. And this is not really helpful at the end of the day. So what we've done is we've taken the low runners of those traditional manufacturing lines. We were able to increase the productive time of these machines significantly. Actually, we tripled it. We brought it to 75% and only at 25% setup time. So we could produce 3 times more parts with the associated margin and so on and so forth in the same amount of time. If you're in a backlog situation where you're completely capacity constrained, this is very interesting. And then it really doesn't matter if the additively manufactured part then is a couple of percentage points more expensive than the traditional manufactured part. So this is something that we should consider when we try to find value for the user. So there are basically 3 action fields that we need to have in mind when we want to transform additive manufacturing from prototyping all the way to industrialization. First is a shift in the mindset. So we need to position additive manufacturing as a strategic capability for value creation. We need to strengthen manufacturing resilience and adaptability in the volatile world that we are facing. And we need to integrate additive manufacturing to enhance basically flexibility, mitigate risk, enable localized production. The second thing is we really need to shape the ecosystem. So we need to transition from isolated pilot use cases towards integrated production networks. We need to leverage partnerships and digital platforms to accelerate scalability. I will come to partnerships in a second as well. And then we need to have standards. We need to have quality frameworks, trusted collaborations in place in order to really trust each other and then scale and shape the ecosystem. And then I mentioned scaling already. Let's scale for impact. So let's make sure that we really have additive manufacturing integrated in core operations and in the supply chains of a producer, of a manufacturer. If they run their traditional factories and then additive manufacturing is so complex from a system point of view that you cannot integrate it into the standard workflows, then it will be very difficult for additive manufacturing. At the same time, it's really necessary to achieve speed, flexibility, and sustainability at industrial scale. I mentioned partnerships. So one example of a very good partnership in the industry is the AEM Impact Navigator. So the purpose of this AMI Navigator is really to provide a strategic framework to accelerate additive manufacturing maturity. And when you look at all these logos there on the slide, you basically see that a couple of industry leaders have joined forces to make sure to jointly build a partnership to bring the industry forward. And the Additive Manufacturing Impact Navigator is a framework, is a maturity model that covers all the different dimensions of additive manufacturing readiness, like strategy, materials, and so on and so forth, and allows you to really build a progression path on how to scale up additive manufacturing at any company. With that, let's move into the second trend that I see, supply chain resilience. So when we look into the world around us, there's a lot of trade volatility happening. And that volatility that we are facing outpaces basically the way how we could traditionally respond. Well, in April 25, you all remember that one picture in the Rose Garden of the White House, where suddenly the US raised tariffs sharply. This is, of course, a major disruption, but it's only one of the many disruptions out there. We are facing wars, we are facing geopolitical uncertainty, tariff tensions, trade tensions, sometimes ships park wrongly in the Suez Channel and break down basically trade routes. So there are multi-regional dependencies that we need to manage. There are complex logistics in place for just-in-time models. And we are exposed to pricing instability, customs, and so on and so forth. So this is a world where additive manufacturing actually is really a strategic opportunity. On the one hand side, it can boost our geopolitical resilience because we are not dependent anymore on logistical disruptions, because we can actually locally produce. We don't need to ship products, we can ship data and then produce where we need to produce the parts. It gives us operational flexibility. We can print parts on demand where the customers are. We don't need to have full-scale production lines at a global hub somewhere and then rely on smooth supply chains. And also that allows us being speedier to market, so we can respond much faster to regional demand and shifts in demand especially, and to regional sentiment, the regional cravings for product updates. And last but not least, there's quite a sustainable impact of that as well. So if you're able to reduce the CO2 emissions from freight, reduce material waste with additive manufacturing, that will also help us on the sustainability agenda. So basically, when we think about strategic resilience, now is the time to act. Yeah? And there are 3 concrete actions for me that players should do. So first of all is identify portfolio opportunities. So think through what are suitable parts in your production portfolio that you can move over to additive manufacturing. I'll talk about one of the tools out there, the Additive Manufacturing Opportunity Screening tool. There are many tools out there. We have also built one at BCG, so I'll dive into that in a minute. But the key thing is identify the opportunities in the portfolio. Then define the additive manufacturing strategy. So really align the AM adoption with the cost structures that you see, with value, with operational priorities, and of course market needs. Because we don't do technology because it's sexy, but we want to address a market need with that. And then let's start pilot programs. Let's make sure that we test feasibility fast, that we show that the return on investment is there, and then scale fast. And leverage service providers to bridge the gap if you don't have the CapEx yourself at the moment. Diving into that opportunity screening. So basically the idea is, and a lot of different tools work similarly, there's a screening algorithm that looks into the technical feasibility of a part. So can you actually additively manufacture that? Is that possible to additively manufacture? Once that is tick marked, then it looks into the economic feasibility. So is it actually economically viable to produce a part additively, or is it non-economic? And then last but not least, you also need to identify what is the right technology to actually produce it additively, because there's a multitude of different technologies out there. So we of course need also to understand for a given part, for a certain application, what's the best technology. And that allows you to identify the best additive manufacturing candidates in your portfolio and then shift them over to additive. Looking into the third element, the digital and AI. So when we look at digital and AI trends, they will accelerate the maturity of additive manufacturing significantly, and they're actually doing it today already. So think about software corporations. So establishing new corporations, facilitating the integration of additive manufacturing into conventional manufacturing technologies, making sure that we have that software corporations in place. Second thing is digital integration, making sure that we have software in place that allows us to integrate and connect 3D printers with the factory shop floor. So making sure that we can bring that together in a manufacturing execution system, that you can use the same system for traditional manufacturing as well as for your additively manufacturing technologies and printers and machines. Because at the end of the day, a user of a technology will only use a technology if it's seamless, if it's no trouble for him to operate that. And last but not least, Gen AI applications will simplify the way how we do 3D printing significantly. And I'll double click into Gen AI opportunities in a minute, or AI opportunities in general. And they will help us to reduce development cycles. And looking into Gen AI, there are six things where I think Gen AI can actually boost additive manufacturing and vice versa. So on the one hand side, of course, product design. Generative design, we have heard it, we see a lot of different booths here that promote generative design. So I think this is, of course, one thing that can help us to optimize topologies and optimize basically also the way how we have structures in place and so on and so forth. But then there are a couple of other things that are not that obvious. One, for example, is material handling. So we have seen a couple of robots when you look around here, so they handle the material as well. So we can generate synthetic training data with Gen AI for basically automated AM powder handling and so on and so forth. Yeah? So we can generate this training data to train the robots, to train automated systems. Going the next step, automated engineering. Of course, automated generation of code will also help us and will help us in simulation, will help us in the models for AM production workflows. When it comes to equipment maintenance, we can actually have an automated generation of maintenance and calibration instructions for AM equipment that you can also, of course, do with a traditional manufacturing, but also, of course, for AM. So we really need to think how we lower the hurdles of the adoption of the technology. We can, of course, have AI-driven operator support, helping them to operate the machines, giving them work instructions, standard operating procedures, and so on and so forth. And at the end of the day, also when it comes to advanced shop floor automation, that's then more like physical AI instead of generative AI. But here we can also, of course, have autonomous robot control of the AM production process, especially the post-processing as well, integrating that and the pre-processing as well. So with that, let me dive into the last trend for a couple of minutes. So this is really about the material and the equipment innovation. So innovations enhance the performance and drive cost-efficient additive manufacturing at scale. On the one hand side, we see a lot of material innovations, also when we look around these halls here. So we see advanced alloys and advanced powders. So really next-gen materials that help us to unlock the next generation of applications and further use cases. We see high-performance polymers that will also unlock through their tougher, lighter, more sustainable appearance, new sectors for industrialized additive manufacturing. And we also see specialized ceramics that will also be very interesting when it comes to those ceramic applications where you suddenly can print things much smoother with a much higher quality than we've seen it before. At the same time, we also see quite a bit of material and equipment advancement. So reliable and sustainable performance is one of the things that is pretty much promoted by the equipment providers. We see more reliable performance, sustainable performance. So with additive manufacturing, when we are not there anymore where we were like 5 years ago, where it was always, a bit of a gamble, whether the print job was exactly the same like the print job before, we are past that stage. Now we have really good continuous quality coming out of the systems. We have autonomous production where we can basically see where we can support 24/7 printing by connecting pre- and post-printing processes. And we have higher throughput printing when we look around us. Also, a couple of players out there that really promote the speed of the printing process. So a lot of things are happening here that make me very positive about the future of additive manufacturing. So 4 key takeaways for you to take from this talk. So additive manufacturing is really a strategic opportunity, yeah? And there are a couple of reinforcing trends to drive value in the industry. So first of all, additive manufacturing can unlock value across multiple levers. So let's think about the total cost of ownership that additive manufacturing brings to the table, not just direct part comparison. So there's a lot of more things that you need to consider to create value for the user of the technology. And let's drive forward on industry partnerships. Let's make sure that we partner up to drive additive forward. Additive manufacturing can play a significant role in de-risking supply chains with distributed manufacturing and the like. That can help us to build the geopolitical resilience muscle, and let's use additive manufacturing for that as well. Then digital and AI solutions will boost productivity, and we see that already around here, that productivity is increasing significantly. And also the material and equipment innovations that we are seeing, they will enhance the performance. They will enable us to scale additive manufacturing in a more cost-efficient way very quickly. With that, thank you very much. There's a lot of further reading that you can do. So BCG has been one of the first to understand the transformational potential of additive manufacturing. So you find that on our website if you're interested in reading further. So now I'm very open to questions from you, or just connect via email or LinkedIn, and we follow up separately. Thank you very much.
Wilrich, fantastic. The good thing is, I'm really happy that I'm allowed to ask you questions, basically. Because, you know, if you're sitting here on stage and you have this panel discussions to a certain topic, you have keynotes to a certain topic, then it's so good at the end to get a summary, and not like a summary of feelings, because I mainly experience feelings or open questions. So it's good to ask you some more questions to either confirm my feelings or probably not. That's a big question. So we just in the supply chain panel, we talked about the issues they have, and I thought we were much more ahead to that. How do we get more awareness? I mean, you mentioned the trends, the good things about additive manufacturing, but how do we get more awareness in the industry of getting more into the use of additive? That's the first thing. And not only by education, but that this is really an alternative. Are we there that this awareness is there, or do you still think there's a way to go?
Well, I think there's still a way to go, but what makes me very positive is when we look, for example, at how the booths are generally constructed here at Formnext, there's a fundamental difference to how the booths were looking like 5 years ago. When I was here 5 years ago, I was looking at all these different tech equipment pieces. All producers have put their machines there, and I'm an engineer myself, so I was of course fascinated by that, but you don't get a manufacturer or somebody who has a problem excited when they look at the machine. They want to see the application that they can use that technology for. And the technology doesn't really matter at the end of the day, as long as they get their problem solved. And when we now look at booths of the different equipment providers, of course, you also see a couple of equipment pieces, but you more and more see the applications and the possibilities that the technology can do for you as an interested user. And I think this is the way that we need to go in the industry. Really think where the user have their problem, meet them where the problems are, and offer solutions and not just technology.
That's a perfect transaction to my next question, because I mean, we talked a lot about thinking more in verticals. And when I think about the solution, I'm coming here as a manufacturer of a good, whatever that is, could be a car, whatever that is. So I don't want to collect the single pieces of supplier need. Like I go to the machine producer that might supply me with a machine that I can print the parts. Then I need to go to post-processing. So do we need more collaboration in terms of supply chain inside the industry in order to really show an offering where the end customer in terms of industry understands, oh yeah, if I buy this supply chain, then I have the solution. Is that what we need?
Absolutely. So we need to think about partnerships. We need to think about integrated solutions. Because if you come, for example, as a car manufacturer to Formnext, and then you realize, there's a lot of different things out there. So where do I need to go first? So it's really a maze, a labyrinth of different things, technologies, pre-processing, post-processing, the production process itself, materials, and so on. So actually what you're looking for is a solution provider that helps you identify what you need. And then ideally a bit agnostic of the different technologies or materials. And I think this is where those partnerships really will help us. So that we can take the user by the hand and say, look, what's your problem? What's your challenge that you want to solve for? Let's find the ideal solution for you without the need to go through 20 different 20 different stakeholders.
But that leads me to AMI Navigator that you mentioned, and I'm so glad that you partner with them and be part of this program. So we had them on stage. We discussed AMI Navigator, and I remember that 3 years ago when we started the whole initiative. So isn't it? Shouldn't it be the outcome, probably with the use of AI, that I use the AMI Navigator to explore my maturity level regards to additive manufacturing? Then in the next step, get exactly the steps that I need to do. Is that not the next logical step?
That's exactly the next logical step from that we would see from such an initiative like the AM Navigator. It helps you. You can also do a self-assessment. It helps you to understand where I am on the curve of the maturity curve. And then it helps you also to identify directly what are the next steps that need to be taken in order to go to the next step and to the next step.
Because I think we need a plan for the industry to understand. Let's talk finally a little bit about money. That's my favorite topic, to be honest. So if we see all the consolidation taking place, so there's a lot of M&A activities. So we see people building up a supply chain, people building up more competence in a specific field. So how do you see the consolidation? Is it more like going into a positive direction? Because consolidation always means we are maturing, basically. And is it in the right way, or is it somehow still not in the direction we just discussed to get more into verticals and more into a whole supply chain?
So I would rather see it. I would not see it negative at all at the moment. Yeah, so it's a sign of change. It shows us that there's a lot of change happening in the industry, and change is always an opportunity. And I think we are shaping now the future of additive manufacturing. And these consolidations that we're seeing and the M&A activity that we're seeing will help us to have stronger players eventually that then will be able to drive innovation forward. So I'm rather optimistic on what we're seeing at the moment.
Talking about profitability, if we talk about profitability, I mean, you as BCG, you look at it in a very holistic way. You are allowed to, or you should to. Let's put it that way, if we see your task in this whole thing. So is it more important to create profitability on the end user side in order to enable the industry, if we still talk about an industry, to increase the profitability, or shall everybody look at itself and see how this smaller part of AM creates more profitability?
So in the broader scheme of things, I think in order to enable a takeoff of the, or further takeoff of the industry, we need to make it appealing to the user of the technology. Yeah, so that means also that they see the benefits overall in driving additive and trying out that technology and training their people, investing into that training and so on. But on the other hand, we can also, I mean, the industry is not a charity, yeah? So we also need to make sure that the players and the participants in that ecosystem, they earn decent money to stay on board. Yeah? So that is the trade-off that we need to balance.
What I really liked about your presentation at the very beginning, you mentioned the drivers. So there was like sustainability, like the technology freedom you have right now. What is in the meantime the main driver? Because I remember the last 3 years we talked a lot about sustainability, but in my opinion, it's still not the main driver. So is it rather getting to more? And you mentioned this nice use cases in the production to get better. Is it getting more efficient, more profitable, or is it sustainability? What is, in your opinion, so the main driver where probably our industry should focus at?
So I think naturally additive manufacturing was always placed at that technology that can solve, you know, the most sophisticated use cases, the most sophisticated challenges when it comes to design and so on and so forth. What I realized actually is when we want to scale it in manufacturing, often those, you know, complicated designs, of course, they're important, but they're not the decisive factor. So that example with the capacity unlock that I mentioned, these were super simple parts, the simplest part that you can imagine. Yeah? But they actually drove that company to buy 35 printers to really scale additive, to build factories, to adjust their factories in order to put the additive manufacturing printers inside the traditional manufacturing sites. So we also need to really understand where the problems of the users are in order to go that next steps, to identify that value.
That's a good one. That's a good closing word, by the way. So focus on what the end user's problem is and solve it. That would be the main driver. Like, it's a very traditional approach, but I think the most successful one. Thank you so much. Big applause again. Wildrik, it was a pleasure having you again. The perfect wrap up for the Formnext. So big applause, ladies and gentlemen. Wildrik Heising, was a pleasure to having you. Really, please, thank you.
Thank you.
So, ladies and gentlemen, I think this was really an exciting wrap-up for our 4 days here in Formnext, but we are not at the end of our program, and you should stay tuned, because at the very end we come to the grand finale. We will hear the persons behind the Formnext, and it's super interesting for you probably, in order to get a touch and feel where we stand at Formnext as the indicator for our industry. So stay tuned, enjoy a little bit of Formnext highlights, and we will back with the persons behind Formnext in a second. See you there.
You might have thought AM is all about big machines and raw materials, but it can do glam as well. We're here at Ledgers. Let's see how they can glam me up.
Yeah, I saw Dominic on LinkedIn, and he's doing really well in building a fantastic audience in LinkedIn. Yeah, I think with the challenges in Germany that we have at the moment in the manufacturing industry, we're really in need of fresh talent, of young people who bring the industry forward, and with that, of course, also the additive manufacturing community. And I hope he makes the most of this week.
Ich arbeite mit Firmen zusammen, die dann wirklich genau den Hexcode anmischen, den ich brauche. Für Anfang nächsten Jahres ist das Ziel, auf die Dachregion zu skalieren und dann zu schauen, wo man hinkommt.
Die Kamera läuft und bitte.
Dominik, du bist ja einer der jüngsten Gründer Deutschlands. Was interessiert dich an der additiven Fertigung?
Für mich ist das Coolste eigentlich daran, dass du bist in den Möglichkeiten wirklich unbeschränkt. Also das Einzige, was dich beschränkt, sind deine kreativen Ideen und ansonsten es steht dir alles offen und das finde ich halt wirklich sehr cool.
Wie bist du dazu gekommen? Also bist du morgens aus dem Bett gepurzelt und hast dir überlegt, additive Fertigung, das ist doch meins, oder hat sich das einfach so entwickelt?
Ich habe früher 3D-Spiele entwickelt, das heißt, ich habe schon früh angefangen zu modellieren und dann wollte ich eine dieser Figuren, die ich erstellt habe, mal auf dem Schreibtisch stehen haben und dann war halt das naheliegendste, einen 3D-Drucker zu kaufen und so kam ich dann in die Szene rein. Also ich glaube, den Drucker habe ich so mit 9 Jahren ungefähr bekommen von meinen Eltern.
Und deine Produkte, haben die sich verändert? Gibt es da irgendwelche Visionen, die du hast, wo du sagst, das will ich unbedingt noch mal erkunden, oder spezialisierst du dich?
Ich probiere stetig, meine Produkte weiterzuentwickeln. Anfangs war ich ein einfacher 3D-Druckservice. Jetzt habe ich mich auf Werbemittel spezialisiert und immer weiter Dinge probieren, um dann einfach eine bessere Qualität.
Yeah, for Siemens Energy, Formnext is a key fair, and it's really a melting pot for all additive manufacturing technologies. And we are meeting vendors, we meet suppliers, and we meet also our customers where we deliver parts to.
So Formnext is very interesting for us because we use a lot of 3D printing in-house and also for our production parts. We use it in-house for product development and concept verification, also for testing. We use it, like I said, for our production parts as well. So it's good to see all the different capabilities of the printers here and the different materials, as well as like the 3D scanning aspect as well.
So we are focused mostly on the maritime sector, also motion tooling, research centers, universities, and on the additive construction side.
We want to see the newer materials that are released, also the new machineries. We are based with mostly polymer systems, but we are also looking very much now into metal powders and metal AM, which is very interesting for us.
I come to Formnext because I'm a student. I'm studying mechanical engineer, and it's very interesting to see everything about 3D printing.
Formnext 2025. We're moving towards the end, it's the last day, and if I were you, I'd have some serious FOMO. You might just miss those latest innovations on the market. Get yourself here. Formnext 2025 was absolutely amazing. From tech to innovation to a global network, it quite literally blew our socks off. Hope to see you next year because you've become part of the family. Take care.
Welcome back to Formnext 2025 and welcome back to our live stream here from Industry Stage in Hall 11 in Frankfurt. Wow, time runs fast. It's 10 minutes ago that I sat here and introduced you to the fair and to the beginning of the fair. And now we have the after work session, or we can say the after exhibition session. And some feelings are being happy, being glad, but some feelings are being sad as well. Maybe we have a look if my guests join me in my different feelings. Let me introduce our guests here. You all know them, but better to introduce them. Sascha Wenzler is Vice President of Formnext, and Christoph Stücker, he's Vice President of Formnext as well. And of course, Sven Krause, my co-host and friend here on stage. Yeah. Happy faces, smiling faces, exhausted faces from partying yesterday. Before we dive into these feelings, we may have a look at the highlights the fair brought to us and brought to you at home at the live screens.
Formnext 2025. We're moving towards the end, it's the last day, and if I were you, I'd have some serious FOMO. You might just miss those latest innovations on the market. Get yourself here. Formnext 2025 was absolutely amazing. From tech to innovation to a global network, it quite literally blew our socks off. Hope to see you next year because you've become part of the family. Take care.
Wow, so cool pictures. What do you think when you see the collection of thousands of faces and products and things? You made it happen here.
Yeah, it's the smiles. What should I say? Thanks, Sven. Christoph, it's the smiles and the faces. It's the crowdy halls. So the visitor flow was massive. Massive visitors and fresh new visitors, young visitors coming in, joining the professionals, the atmosphere. Everything was like a firework. And then you just mentioned it. It's always so positive and this energy here inside, that's incredible. And then on the other side, you think, hey, wow, it's already over. And I think that
so
creates
fast.
this kind of little sadness.
It's like a time travel, right?
Hey, we just started 10 minutes ago,
It
and
feels
now
like-
we're already finishing it, and it's overwhelming. 10-year celebration, anniversary.
I was thinking of the party yesterday. Yes. You know, we went to hall 5.1, the new hall here on the exhibition ground. And we went there, and first you have nobody there in the long aisles and so on, and then you come into the hall and it opens and party. There's a party, and all the people are there, all good feelings and Spain, Spain food and Spain party going on. So, how long did you stay there?
Oh, indeed, I have kind of official task, so I'm also closing the party. But maybe next year somebody else, maybe a little bit younger, can take over this. So I always stay really until everything is empty again, the regular lights go on. But yeah, I think it was 1 o'clock in the morning, so still okay.
So Christoph, I saw you dancing yesterday.
Did you? Good.
Yeah.
Yeah.
Did
you see the performance of the whole team?
Very cool move.
Okay.
Yeah. Did you make some new contacts on the party?
You mean dancing-wise? To hire us as a dance group.
Yeah, that would be a nice one.
I think, yeah, I think
second career.
it might be a new business model for us. Let's see what happens.
Yeah, maybe.
I think everyone performed really well, so you know, it's good. It's good fun.
I very much loved the cubes, the light cubes, the bulbs over the stair
on the
stage. Yeah.
Over the band where the band played.
Yeah, I loved them.
Yeah.
Maybe we get them next year here on our industry stage as well, because then we have a evening party every day here.
Yeah, I think that was a great combination. Moving to another hall, to a very new hall, and they are having the 10-year celebration party. Incredible. Nice party, nice people. Hey, we have a nice family.
But the exhausted faces, Sven, are not only because of the party yesterday. The exhausted faces are because of a lot of discussions and a lot of talks. Maybe Sven, you share one of your highlights. You hosted so many panel discussions here on stage. What's in your mind?
That's the funny thing is, and especially I thought about it all the time when we were sitting here and up front already. There's something happening this year, and it's probably because we have our 10th year anniversary and we're talking so much about it, that I realized something. I want to share that with you, and it shouldn't be an official statement. I'm not allowed to do so, but you see there. I'm doing this now for quite some years, and I saw the evolution, or call it revolution, as we call it in the awards, and it's so impressive to see, like we came from showing cool machines over cool applications, over talking about consolidation, now talking about profit. And honestly, I love that. I never experienced that, to be part of that over such a long time. And the second thing is that you still have tradition and stableness in a certain way, because this is why wearing the family shirt, you know, this hasn't changed over time. And usually if industry matures, this goes away after a time. Yeah, you no longer feel it. And I still come here and have this strong feeling of everybody knows each other, and even if you're new, you get into it so easily. And on the other hand, we are much further away from what we started 10 years ago. It's the progress is incredible, and that's the feeling how we're leaving, to be honest. Yeah.
Yeah. No, it could be seen as a trade-off, but really what we try is to embrace it and sort of preserve that family feeling.
And it works. It's
and,
incredible.
You know, infect other people with that.
Yeah.
Positively.
Exactly, Sven. You know, it's like being a life attendant in the theory of industrial maturity cycle.
Yeah.
And that's we all experienced it the last years. That's great. And yeah, I just can maybe not hope, but the additive manufacturing industry, all the people involved in this technology, the family, like you wear it. If they can keep this spirit, I think that's also a very important part of having a further successful development of the technology, of the adaptation of the technology. Because still, when you really believe in the possibilities of this technology and you talk to new customers or new people coming in, or even the younger generation, the kids, the students, no, they all become these shiny eyes, and that's very good, even for a maturing industry and in a more and more professional context. And naturally, it's necessary to talk about business. Why not talk about business together with this fascinating?
I remember because of maturity, your panel this morning. I love the sentence. I'm not sure if you said it, Sven. So we solved a lot of problems, and now we're coming to solve new problems, and that's
more, by the way.
Yeah. And more. But you know, that's one aspect of the maturity of the market. So the problems will never end; they will just change.
Yeah.
But I think what's charming with additive manufacturing and 3D printing is really that it still has the charm and the I don't know, the glamour of the technology. So it inspires a new generation, as you say, you know, the young people that come to Formnext, who may be the engineers of tomorrow. Even though it's mature, it still has this glamour, and that's a real chance for additive manufacturing.
Oh, there I have another highlight for you. We had Sophia here on stage and with a design panel, and she showed one of her products she designed or she printed, and it was a Christmas tree, I don't know, bulb. But it's not quite a bulb. And it looked very shiny, very nice. Okay, I saw it. this just an example for nice design as, you know, nice to look at. And I'm so glad I had Andrew with me here on stage, and he had the 3D, the additive idea in his mind already, because he said, so you have this spin because you printed in a little indifference so that it has a special spin to it. And Sophia said, oh, yes, you recognized. And I very much love this example because you have a shiny product and it really looked special, and you have it's an engineering product.
It's a function inside.
It's a function inside you only can have with 3D printing.
Yeah, but
I love this.
Not taking away of you two as the responsible, all your conclusions, but one more conclusion came into my mind. You know, I discussed with a lot of the exhibitors about, and you heard it, do we have to think more on verticals? And yes, that is true. And then probably the question might come up, do we need a Formnext in the future? Why not we're going to all the vertical fairs? And I tell you why we need the Formnext even more than ever before. Because the problems we discussed today in supply chain, we discussed in business cases, wherever we discuss it, can only, I promise you, can only be solved in such a fairground, in such environment, because it's all about collaboration. That was more clearer than ever this year. And I remember talking to Martin from the European Defence Agency. He said the main reason coming here is because in these 4 days he solves more problems than anywhere else. And we'd have to take this as a real chance, because this Formnext, sometimes you think, why is a fair necessary? But this fair really solves problems and drives the business.
Yeah, it's a transfer of knowledge. You experience here on stage.
We had a very similar conversation, and you can learn from other industries. Someone may have solved your problem in a different industry, but you never meet this person unless you come to a melting pot of AM.
That can only happen here, and it's not. This exhibition is not mainly about sales. It's not the main driver. Is not to sell a machine, especially not in additive manufacturing. Everybody knows this now after these 10 years, because it's a trade fair for exchange, for know-how transfer, for learning from each other, and for offering solutions to the customer. And then when you talk with the customer about the product, about the problem, about the materials, about the different processes, what's all possible with AM, finding a good solution, then the sales is one of the last steps. So it's kind of other way around. Some years ago, or a couple of years ago, it's always the thinking, hey, I need to sell a machine and everything is perfect. This is not happening in additive. So finding the solution, finding new solutions, coming from a product to think about the way how to process it, that's also a different way of thinking. And additive always needed a different way of thinking how to design a product. So these things are coming together in these halls with all of the suppliers and the users. And that's the driving force to bring additive one further step forward.
Christoph, can you bring in some other highlights from the other hall, from hall 12, or from other stages, or from other conference meetings, or something you might have? We didn't have the chance to follow.
You're not alone. No, we have the same challenge. Obviously, we have plenty of meetings throughout the week. Schedule is full from morning till evening. However, there are little gaps between. So sometimes we walk the show floor as well. Obviously, I'm also involved in the stage program set up together with my colleagues. And there were some, again, you mentioned already, focus on the applications, focus on the business cases. So that's something we really tried to put into our stages. And I think we did well. The stages were full, were packed. Everyone was very interested in the talks.
From the first start and on Tuesday morning here, the morning talk, it was every row was full.
And that really shows the demand for this exchange that we would like to further. And that the same principle holds at the booth as well. I mean, I chatted to a few people, and we had the same discussion. We have to show the solution, show how a problem can be solved, and that's also happening on the show floor all the time. And You mentioned it, the halls were full, were packed. So there's a huge interest in this technology and in problem solving.
Talking about full, people are always interested in concrete numbers. So maybe you give us a short overview, exhibitors and visitors. That's always what people want to hear, especially in these tough times.
Yeah, exactly. You just mentioned it, tough times. Tough times also mean in a consolidation phase, and we read it and heard it just in the session before from the colleague from Boston Consulting Group. In a consolidation phase, companies leave a market. Some of them do it by purpose, and some of them by force to be driven out of the market. That's what is reflected on the show floor as well. So from last year's 864 companies, we have 804 companies this year on the show floor. 62% of them international ones, and that are all relevant companies in the additive manufacturing supply chain. So the suppliers, all of them are here. And then the next number would be the visitors. You never know on the first day, when we started 10 minutes ago, how the visitors will come in to this trade fair. And the answer is, and you also just said it, it's massive. It's a massive inflow of visitors, new ones, young ones, together with the professional ones. This mix, I think, was our experience for the first time. More and more is taking place, this mix of different generations, different mindsets. So the detailed number will be published, I think, late the afternoon, 4 o'clock. But what I can really tell is, and that's what we are so proud about, to have reached this, there will be several thousand more visitors than last year. And that's the main message. Additive is attracting more and more people. And bringing more and more people in the technology means at the end also more possibilities and more business. Absolutely. So absolutely great results.
No, that sounds really good. It's promising. So that means tough times doesn't always mean people stay at home. And good. And it was, as I said, it was what my short part of the picture. What I can tell, that was the same impression. Yeah, maybe let's have a look at, we have the partner country. I mentioned it in the party, but maybe you give us some insight about what went good with Spain as partner country, what brought they to the fair. And then the next step would be that we talk about the partner country next year. We already had them in the morning talk, but maybe not everybody had the chance to follow it. Maybe you can tell us about the partner country and a little bit about the concept behind and the partnering behind.
I mean, we always want to highlight specific countries and regions and ecosystems with the partner country concept. And Spain was the choice for this year, which we really enjoyed. What else could I say than they bring passion?
For sure.
And they were on the award shortlist yesterday as well.
Yeah.
No, we have two finalists, by the way, one winner of them. Absolutely. So we had David and Nayara. Yeah. So this was incredible as well.
Fantastic. And those two are also our partners for this concept this year. And they were fantastic to work with. Really passionate people, very driven people and motivated people. And that holds for the whole Spanish ecosystem. There are fantastic companies here on the show floor that you could experience this year and hopefully next year again, of course. So yeah, absolutely lovely to work with.
Yeah, and maybe to amend also the idea with the partner country is that that's not only happening only 1 year. So when we look back, we created through the partner country concept also long-lasting connections and partnerships between the partner countries, the partner regions. So the Nordic guys are still in contact, for example, with the French ones, and now they met the Spanish ones. I think that's important.
Absolutely.
Because then also what we can't do as an organizer is we can bring them together, but to collaborate together with all the different initiatives, associations, everything what's going on in these nations, that's extremely important in these times in Europe as a whole, to unite all these bright minds and these forces. And so to create this joint interest.
Absolutely.
Is there something special we can expect from next year? Appearance of UK?
Well,
What
UK
we
is-
already can say.
Well, well, definitely British food. That's set for the party.
Watch the morning talk. Watch the morning talks this morning.
Okay,
where the guys
should have been a
here.
pitch. No, the UK, partner country. So, I mean, they have a long heritage in additive manufacturing in different industries, in aerospace, in motorsports. So very, very strong foothold in additive manufacturing, which was part of the decision to choose UK for next year. And as Sasha said, of course, there are different perspectives. You have your regional initiatives, regional ecosystems, national ones, and now the European one as well. So we would also like to strengthen the European ecosystem as a whole by choosing UK as well. And then, of course, there are fantastic companies, great users of the technologies, and those we would like to highlight and we would like to invite to join us next year, specifically from the UK.
So maybe our audience should stay tuned because there are some projects coming from UK side or from your side to get the visitors and the exhibitors to the stage or to the fairground and then to the stage next year. Yeah, here's 3 guys. We are coming to an end of our live stream. Exhibition is still going on, some hours here. So dear visitors here at the stage and at home, unfortunately you cannot do the contacts from home, but you can do the contacts in our LinkedIn live stream. And I would ask you to make the one or the other comment. Maybe you have some hints for us what we can do better in future, or maybe you just give us some kudos. And kudos, that is my buzzword, because I don't want to close here the live stream without giving kudos to our team, to all the people who are behind the stage, who are behind the cameras, who are behind our microphones. And so I beg you, 3 guys, to stand up with me, to come to the middle of our stage. And I want to have you, my team, the team of Formnext, coming to stage.
So,
Thank you, guys.
Latschen mit Sektglas ist schwierig.
Danke dir. Danke.
Cheers.
So come on, everybody. Now I have to talk to this camera over there.
Good job, vielen Dank.
Because nobody handles the live stream. If my voice is too low or too high, nobody will adjust this.
Symbol.
So thank you very much, all of you.
Shout out to you guys.
It was a pleasure working with you again. Come here, into the light. Come into the light. Nobody's biting you here. Come to me. Yeah, that is a lot of people, but that's only a part of the people working here to get all the topics on stage, to get it all happened before the exhibition, while the exhibition is running, and after the exhibition it goes on and on. So I have to send the ones of you back.
Thank you.
Back to stage.
Cheers.
Back to your desk.
Because otherwise we will not follow on it will not happen anything anymore. Thank you very much
Danke euch schon mal.
for helping us, for working together with us. It's always a pleasure. Yeah, that's the last.
Honestly, guys,
The last moment.
that's the ugly part.
That's finishing a show.
In terms of saying
Yes.
goodbye, I don't like it at all.
But we look forward to the next one.
Yeah, that's a good one. That's a
So
good
we look forward.
So
Oh, cameramans are still installing themselves.
There's a red light.
There would be my camera, and I would say thank you, the audience, for watching us. Thank you for being with us the whole week, and I hope we will meet again here in Frankfurt in 2026. Stay tuned till then. Thank you, guys.
and keep up the speed and work on additive manufacturing, so we can have next year a much more successful fair than this year. That would be great. So stay tuned.
Have a good year.
Thank you.
Oh, come on, Lisa. Shut up. This is ridiculous.
So, what have we got so far? Any brilliant ideas for the anniversary?
People, program, process, popcorn, and party.
Pole dance.
Professionalism.
We show people. Professional people.
Smiling people? No, please. Not just a parade of happy faces.
People,
Talking about where they're from.
No time for that. And how does that connect to additive manufacturing?
Right. Because they're holding something. A part. A cool design. Something 3D printed.
Let's hope your enthusiasm can save the pitch at 11. We'll need all of it.
Let's show the products. Think of commercials. For car porn style. This is gonna be hot.
Why not add some bad taste erotic music?
Let's not.
Yeah, let's not.
This project is killing me. It has to be something special.
Something special. Something specific. Specific industries.
Aviation aerospace? Lightweight is important to them. Engineering and construction? Definitely big ones in 3D printing. They'd love to see that too. And jewelry is on the rise. They sure expect more visitors from this sector. Don't even think about bringing up Paul.
But he was the secret star of the last exhibition.
Still can't believe it.
What about the faces behind Formnext, the organizing team? We have event management, sales and customer care, marketing and communication.
Exhibitor services, new sales, and the management. With Christoph, Sasha, and of course, Petra. Though I can already hear her say, I don't think this is gonna work that way.
Can we cover the entire process chain?
The entire process chain?
The entire process chain.
Epic film.
An epic film with huge machines and massive booths.
In slow motion.
Awesome.
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 That's literally every other trade show video.
Let's break expectations and we finally deliver something truly fresh. We show how AM works in production.
Done that already. Application Insight at Audi 2023.
Or we show the unique benefits of 3D printed parts made of special materials.
Done that already. Technical Ceramics, Exhibitor Focus 2024.
Or we dive into different 3D printing technologies.
SLS and SLA Technology, Exhibitor Spotlight 2022. Done that already.
Done that already.
Yeah, we do that every year. We need to nail this. We need to deliver something truly special.
So what do you suggest?
How about we finish with a conga line?
Oh, come on, Lisa. Shut up. This is ridiculous.
Woke up this morning. Now watch me step. The week was murder. I'm gonna get rid of the stress. I'm feeling lighter. I'm finally feeling like I can breathe. The night is calling. Tension, gonna blow in a breeze. We're rolling downtown. We're grooving to the sound. We're rolling downtown. The weekend's here and it feels so right. I think I'll break the skins out tonight.